Alright, hell yeah. So we have Professor Povey's perplexing problems. And now this one I can't solve. So I'm not really going to show you the answer, but I'm at least going to show you what it's called. It's called intersecting circles. And cool, let's get right to it. So I'm going to try to solve this from a different perspective. Now I want to get the right answer, but the first thing that we should do is have just a guess. You know what I mean? So that it is. I never think of that, but I kind of developed my whole channel, even though I don't go over this a lot. You know, the whole idea of me making videos is just like, hey, take a problem that you might not be able to do, and then just kind of do the who cares approach. You know what I mean? So if we have, this is 2L, and this is 2L, so we have a box. Then you know, what would be the area of this box? The area of the box would be 2L times 2L. A lot of different ways to do that. You could do 2 times 2, and then L times L. But anyway, so you're going to get 4L squared. And let's try to get some dimensions on this. Oh, and then I guess I'm missing a dimension on this. Maybe I didn't print it, but this is L right here. So this is 2L. This radius is L. This radius of this circle is 2L. And so what should we have L be? Like 1, and this to be 2. So we're going to have a dimension of 2, and then this radius is a dimension of 1. So the area of this circle is now 4. And it's just interesting, like right there, just instantly my mind snaps, and like I understand that. But when the area is 2L and 2L, and the total, I'm sorry, when this length is 2L of the side of the square, and the area is 4L squared, this means nothing to me. Like it's an equation, you know. I mean, we can change L to be whatever. L could be 1 meter, cool, and then the area is 4. L could be 2 meters. Where then this is 4 times 4, and the area is 16. So if we throw in 2 squared, that's going to be 4 areas. So this is an equation. Sometimes it's really difficult to, you know, have an equation and then kind of make sense of it. But it's good to, if you do get an equation, kind of throw in a couple values. But we're going to say that this is going to be 1 meter and this is 2 meters. That's the other thing, is just kind of have some sort of shape to it. We could have said this was just 1 inch and this is 2 inches. And maybe we should do that. So let's, because that gets us a little bit closer to reality. So the area of this square would be 4 inches, 4 inches squared. And now the area of this. So the first thing we can do guessing is just, hey, let's just chop it into fourths. So now I know the area of one of these circles is going to be 1/4 of 4. So that's going to be 1 inches squared, and we just took 4 divided by 4 because we chopped it into 4. Now we're going to do that same thing again. We're going to divide it, you know what I mean? Well, let's see what kind of shape we have here, because maybe if we divvied this up like this, like we can see maybe this shape kind of fits right in there, and maybe it's maybe one of these is an overestimate, and then half of one of these is an underestimate. So even just right there, I have a pretty good idea of what this is. So again, we're gonna just to explain that one more time, I'm gonna divvy this up into 4 chunks. I'm gonna say definitely one of these chunks looks bigger than that area, but then if I just have this much, or half of one of these chunks, that's going to be smaller. And this might not be 100% accurate, but sometimes it's good to you know, have your guessing skills be like, okay, I know the answer is going to be pretty much 99 or 100% between this area, the size of that area, and the size of that area. Okay, let's figure out what we did to get those. So we took this was going to be 1 inch squared, because the whole thing is 4 inches squared, so 1/4 of that's going to be 1 inch squared. Cool, we're going to divvy this up into half. That's going to be 0.5. Divvy it up again, this is going to be 0.25, and divvy it up one more time, that's going to be 0.125 inches squared. So now I know the area of the shaded region is going to you know, approximately be, well, I could say this, 0.125 inches squared. The area of the shaded region is going to be greater than equal to or less than 0.25 inches squared. Okay, so hell yeah. So just right there, that's an important aspect of problem solving. And even if this video goes on for 3 hours, we're 5 minutes in, and at least you learned one thing. Like, take something that, and I can't do this, you know what I mean? I tried, and I tried to do it in different ways of, like, you know, adding these up and subtracting, and I thought you'd get, like, this nice little equation. And I threw in the towel, because some of these problems, they become, like, tricks, where, you know what I mean? If you know the trick, hell yeah, it's, like, super straightforward. But if you don't know the trick, then you're just lost. And so, the whole idea of making this video is I'm still lost on this problem. I do not know how to actually get a precise solution, but I'm going to say, hey, I do know about trigonometry, and I know that trigonometry is for sure related to circles. So if I have a triangle here, I always do like a 30-degree triangle, 0.866, 0.5, and then so we have a side of 1. Kind of the generic unit triangle. This is really important because it really shows you, like, this one's good to do because it kind of shows you, you could put some coordinates on this. This could be the x direction. This could be the y direction. This could be the I hat, j hat. Whoa, 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 whoa. See, if we're going into vectors, I have to slow. Every time I do I hat and j hat now, like, I missed the day that someone said those were unit vectors. So that is literally an arrow in the direction of this. Could be anything. It could be 1 meter per second. Could be a speed of like 1 meter per second, 1 mile an hour, 1 mile a minute. But anyway, so we have a dimension 1 and it's in this x direction. And so the vector, we're going to call that 1 I hat. That is a magnitude of 1 in the direction. And now we just have to say I and x are synonymous. But hell yeah. And then if this is the y direction, you would have a j hat. Well, this vector would be a magnitude of 1 in the j hat direction. Any vector in this direction, let's pick this one. Maybe it's a magnitude of 3. It's in that j hat direction. I don't know. I still... oh, yeah. And then what this says is this is a vector. It's this vector, which has a magnitude of 1, but just multiplied by a scalar. That's why I flip out every time I see, like, what the hell is I and j hat? And why is it representative of a unit vector? Because hell yeah, if we have the vector that's 3, magnitude of 3, in the y direction, we designate this as a vector of a magnitude of 1 in the y direction, multiplied by the scalar of 3. So we're just multiplying by a number. But here is our base unit for that vector. This is a unit vector. So we can take this unit vector, which now we're just calling j hat, and put it... Anyway, so that's a total tangent. So why did I even draw a triangle? Yes, because triangles are related to circles. Because if this is a dimension of 1... this dimension right here is 1. We can sweep this down. We can sweep this into a full circle. And so now we kind of see how a triangle is related to a circle. And so now we're going to start in on trying to solve this. Step 2 is to use grid paper and then, break out a compass. And then just increase our guessing by just a little bit. We're going to hone this in, hopefully, by, well, we're going to have no more than an error of like 5%. That's kind of what we're shooting for. We're going to see, and then it's be fascinated. What is the actual answer? Because if we have the actual answer, then we can kind of see what our error was in this guess. All right, I need to switch batteries, catch on the flip side. All right, back at it. So we're going to grab some grid paper. Now this engineering paper already has, every square is 1 inch. So it's going to be fairly straightforward. We're going to go box in 2 inches. Oh, I can't use this. This ruler destroys my pens. So I just need, if I'm going to use this ruler, I just got to grab a junk pen. That probably pen is already, it kills the ballpoint. So I just got to keep that in mind. Alright, so here's our box, and then we're going to draw these radiuses in. Whoops. Okay, so we got that radius right there, And now we're going to go down to, so that was a radius of 2 inches. This is going to be a radius of 1 inch. Okay, hell yeah. Alright, and so that's our area that we're trying to find. And, oh man, I mean, this doesn't really actually help me. I thought this was going to help me out. I really should do this extra large. But, okay, so I have to throw in the towel because, not on everything, but there was but let's go back to kind of drawing this from a trigonometric approach and seeing what we want. Because there's a few things that I want to, I want to draw this big and then kind of estimate. But even here, I really, well, let's try it. So let's count rectangles. Yeah, why am I freaking out? Because hell yeah, I mean, this is going to be actually pretty straightforward because there's a half a rectangle. This is about a half a rectangle. You know what I mean? Just a little bit more. Keep that in mind. This is another half a rectangle, but just a touch more. You know what I mean? Keep that in mind. And then let's see. This looks like a quarter of a rectangle, but just a little bit more. And this also looks like a quarter of a rectangle, but just a touch more. You know what I mean? And then let's see what this one is. So I would say this is an eighth of a rectangle, and a touch less than an eighth. Same thing over here. So these are about eighths. So I'm going to say both of those are a quarter. So we have a quarter of a rectangle, and then right here I had a quarter and a quarter. So we have a quarter, a quarter, a quarter. So those are those three. Two of these add up to a quarter. There's a quarter. There's a quarter, and then we have half, half, half. So hell yeah, we have this. So this is going to be 1.5, and this is going to be 3/4, which is 0.75. Okay, so right there, now I have my second guess of, then we need to figure out what the hell one of these boxes is, because we only have we got 2.25 boxes. Okay, so now let's figure out what a box is. So this is going to be 1 inch, 1 inch square. And this side is going to be divvied up into fifths. So this is going to be 0.2, 0.4, 0.6, 0.8, and then 1 inch. Okay, so each of these boxes is 0.2 times 0.2, which is basically 2 times 2, which is 4, and then bring back the decimal place, 0.04. And you should always have different ways to kind of like, why is this the case? Because if I had 0.2 times 2, hell yeah, that's going to be 0.4. And then if I had 0.2, I don't know. If I had 0.2 times 0.1, I would have a tenth of 0.2. That's going to be 0.02. 0.02. Cool. But if I have 0.2 times 0.2, I'm going to have 0.04. And then hell yeah. So I don't know. It's just always good to kind of just double check your mental math skills and try to find different approaches. It comes in handy. So each one of these is going to be 0.04 inches squared. And so now we're going to multiply that. I see a 4, I see a 2. So in the end we're going to have 8. And again, let's use this perspective. So if I had 2 times 0.1, that's going to be 0.2. Got it? So 2 times 0.1 is 0.2. And I'm going to say I have 2 times, well, a couple ways to do it. Yeah, I'm going to say I have 2 times 0.1. Okay, what's 2 times 0.01? Well, that's going to be 0.02. Cool. And so I'm going to have 0.02, and then, hell yeah. So this I'm just breaking down to its base unit of 0.01 and then multiplying that by 2. And then I know that I have a multiple of 4. So 0.01 times 4 is this. And so that's what I'm doing. I'm taking 2 times 0.01 to get 0.02 and then multiplying by 4. 0.08 then. So this times 4 is 8. And so we get 0.08 inches squared. That was probably a horrendous way to do it, but the other way to do it is just 2 times 4 is 8, and then move the decimal place 2 places. So we go 1, 2, and we got 0.08. Hell yeah, it's going to be a little bit bigger because we also have 0.25 times 0.4. Let's do that. I know what 25 times 4 is. That's 100. Okay, so, but let's do what's 0.25 times 0.1? Well, that's 0.025. What's 0.25 times 0.01? That's 0.0025. Okay, and then increase this by 4. So I'm going to have 0.0100 added to this 0.08. So cool, I'm going to have 0.09 inches squared. So hell yeah. So 2.25 times 0.04 is going to be 0.09. Is that right? 225 times 4, we have 20, 8, 9, 10, and then 4, 8, 9. So we get 900. Hell yeah. So 225 times 4 is 900. But since we changed this to 225, we got to bring the decimal points right there. If we change this to 4, we got to take the decimal place 2 more. So our answer is going to be 0.09. So just a lot of different ways. People say stay away from your calculator. Well, get ready, because if I'm going to stay away from my calculator, I'm going to have to do this crap like 3 different ways. But that might be the best part of these videos, is be like, whoa, yeah, I dig that. You know what I mean? Just kind of the different perspectives. And what I do right here, I call this the 10% tip, you know what I mean, or the restaurant style, because if I have to do 0.25 times 0.2, I'm just consider this a 20% tip. I don't know how to take 20% tips, but I do know how to take 10% tips. That's 0.025. And then we're just going to double it, 0.05. So that's kind of my style. I call it the restaurant method, and I think I could definitely coin that phrase. Okay, let's throw some more time on the clock and see where we're at. All right, hell yeah. And then you just lose, you know, the forest for the trees, however they say that. But what is this number? 0.09? And how does it relate to what we thought? So it looks like we way overestimated. Like this, I don't know if it's just the way the picture's drawn, but like what does our picture look like? I mean, could we go back and say like, hey, let's do this just a little bit. You know what I mean? Let's just re-guess, because it feels like our initial guess wasn't that great. And let's compare our initial guess just real fast. We had 0.09. 0.09 is our next best guess. We thought it was going to be 0.1. 0.125. 2.2. So this was way wrong, and we didn't even capture it. So there's a potential we didn't even capture the right answer from our initial guess. That's all right though. All right, so I'm going to come in here and I'm going to say, hey, this thing is about 1 inch long. Cool. And then what's its width? Because its width isn't even like 0.7. So we have 1 inch, 1 inch long, 0.7 tall, maybe 0.8. Let's do 0.8. And then and we're going to estimate that it looks like this, because that should underestimate. If we do a diamond shape like this, we should perfectly underestimate, and it looks like we just did, because I mean, no matter let's see, how do you slice this? Because the area of this thing, well, the area of the whole thing would be 0.8, and we think it's we're running into that same issue. No, this is just how many squares it is. Okay, so let's do an accurate guess. So I'm thinking the most this could be is 0.8. Well, I'm gonna say this is 5 wide. So we have 5 boxes wide by 0.8 boxes tall. 5 times 8 is 40, and so we got 0.4. No, we got 4. 5 times 0.8 is 4. And then each box is 2.25. Is that right? No. This is how many boxes we thought we had, and then how are we? Or did we just mess up our guess? No. Yeah. This is probably not 4. That would be a doubling. So yeah, our initial guess of 2.25 was probably pretty accurate. This whole thing, if we box this in, we would get a box that's 4 we would get an area that's four of these little squares. We thought it was 2.25. Yeah, because if half of this, if it looks like a total diamond in there, it's going to be only two of those squares. If this is 5, then that's 0.8. And so this 2.25, I'm going to say that's a fairly accurate guess. So I'm going to say from divvying this thing up, we were fairly accurate on that. Okay, so what's next? Alright, hell yeah. So we're done guesstimating. You know what I mean? So now we're going to move on to what I know about trigonometry. So, yeah, let's get this kind of into a better view. Get it centered. So what I know is that we can divvy up these segments. So I'm going to go from here to there. Hell yeah. So we're just going to segment this up. Anytime that you can draw triangles, for sure, just draw triangles, you know, to your heart's content. So there's for sure triangles, and then we can even just, how many different ways can you connect these triangles? You know, we could do this, and then we could even do this. It's going to make it kind of, you know, we'll do that in a second. But cool. So now we can see that this triangle, well, and then what do we know is that this little pi, so we're gonna do this. This little wedge is a wedge of this full circle. So I can even kind of draw that in, just to kind of give you an idea. All right, hell yeah. So let's draw this full circle in. It's not very dark. And we could do the same thing over there. I just wanted to do that to show you that, oh, okay. So let's say we knew the area of this circle. And you could divvy this area into like 4 segments. So here's a fourth of this area. And then look at this. It looks like we even divvied this up into a third. So this is going to be a third of a fourth. That's going to be 1/3. Times 1/4. That's going to be 1/12 of this circle. And that makes sense. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of these little segments. Okay, hell yeah. So now we're getting somewhere. And we could figure out... oh, and then so when we know the area, we don't know the area of this triangle per se, but we know the area of the full, kind of like a pizza slice. We know the curved crust and then the wedge shape. But then we should be able to, yeah, so now I think, I haven't really thought this all the way through, so I just kind of, you know what I mean, just use whatever knowledge I have, and we'll be able to do this. Yeah, so we're going to go back to that, I love this 30-degree triangle, because if this is 0.66, this is 1, this is 0.5, well, hell yeah, if this is the radius of a circle, we're gonna drop it down. So that's kind of the first thing. Or you could just kind of go all the way around this pivot point. And hell yeah. So this dimension right there is 1. And then you would sweep this up. So you can do, let's draw this one more time. So we're going to do that 30 degrees, and then sweep a circle all the way around. And so this is exactly what we have. We have this at 30, this at 30. Let's figure out how much of a circle this is. Well, if this is 60, this is 60, this is 60, so that's going to be 360 degrees. And so here is this segment is going to be a third. So if we know the area of this circle, this segment right here is 1/3 the area. Sweet. And then we can use what we know about angles. If I know this is 30 degrees, and I know this radius is 1. So my axiom for right triangles, so this is, if this is a right triangle, my axiom is if you know 2 things, you know everything about the triangle. Well, darn it, because that's not 100% true. If you just, no, that's 100% true. I think that is 100% true. So if you have a right triangle, and I know the radius, or the hypotenuse, and this angle, I know everything. I know this dimension. I know that dimension. Sweet. So because when we get to our you know, because if I know the area of this wedge, I'm going to and let's just do half of this wedge. So well, I just know that this angle is going to be let's slow down here. So this wedge, I would know the area of it because I know it's a percentage of the whole circle. Cool. So I know this wedge is 1/12. So then I have the area of the wedge. Now let's say I want to just find half the area of the wedge. Okay, that's just going to be this part right here. And I know this area of half of the area is this curved section, straight section, all the way to there. What I'm interested in is the area of this right triangle. So here's my right triangle, and so we're going to say half the area of the wedge, you know what I mean, is that little thing. So we know the area of the wedge. We're going to take half of it. Or I guess we would say half the area of this whole wedge is equal to the area of, just visually drawing it, it's just going to be that much. But it is this curved part. So now we want to subtract the area of just, you know, half, but not that part. You know, that part we're not going to subtract. We're just going to subtract this triangle. So this is the triangle we're trying to subtract. And what we're left with is that chunk. And once we know this chunk, we're going to know it's the same as that chunk. And we're halfway done with the problem. We know half of this, not half of the shaded area, but at least these two chunks. And then we would do the same process to find those two chunks. And so that's what I wanted to do. But the equations of circles and finding, I think it's going to be a little bit tricky. So that's why I'm still going to take graph paper and try to draw it as big as possible. And then just use protractors to figure out, you know, what this angle is. I'm going to figure out what angle that is and what angle that is. And then we're just set because I have an angle and a radius. So this is, once I know this angle, I know this is going to be 2 inches, and I know that's going to be 1 inch, and then I'm just good. And then whatever this angle is, you know, if I have 360 and this angle turns out to be 22, well, I'm going to take 22 divided by 360, and this is going to give me the ratio. And then if you took it by 100%, I just don't do the 100%, I just know that this is like a percentage. But if you did this times 100%, you would have a percentage of the whole area. So if this angle turned out to be 180, we would have 180 divided by 360, and you could easily see that's 50% of the actual area of the circle. So if this angle turned out to be 180, if this angle turned out to be 90, that's 360. So that's going to be 25%. That's a quarter of the area. And again, if it turns out to be 30 degrees, we're going to have 1/12. So that's 25 divided by 3. Yeah, what was 25 divided by... I know 30 divided by 3 is 10, so this is going to be about 8.5. Is that about right? 1/12. 1 divided by 12 is 0.08. Have no idea. Oh, check this out. If 1 divided by 12 is 0.08, that means that 12 times 0.08 is 1. Never really realized that. And so I don't even know what 12 times 8 is. But let's do it. We have 16, 8... it's like 96, right? Hell yeah. So yeah, I didn't realize that 96 is really close to 1. 96 is very close to 100. And then even when you get something like this with your guesstimation skills, if I thought this was 8%, if I thought 1/12 was 8%, if I have 1/12 of a circle, is that going to be 8%, or is it going to be a little bit more? Because if it was 8%, we would have, well, if it's 12 times 0.08, if I bring this upstairs, This side is less. It's 96. So the only way to get this side, or 0.96, the only way to get this side to be 1 is to increase this number, 0.08, or increase this number. The 1/12th I can't change because I said the angle is going to be 30. So sweet. So I can increase the 0.08. So I'm going to increase that. And what would I increase it by? You know what I mean? If I went to 0.09, well, then I'm going to have another 12. You know what I mean? So 96 to 100, if I added 12, that's going to be 106. So I'm sorry, that's going to be 108. So if I have 96, all I need is 4 more. So I don't need 12. I need a third of 12. So a third of 12 is 4. So I'm going to have 0.084. So there you go. Like if you don't want me to use the calculator, and it is true, you're going to learn a lot more. But if it's your first rodeo trying to use mental math, and I mean, it's like whole separate videos just doing that. So hell yeah, 1 divided by 12 is 0.084, and hopefully it's wrong. So 1 divided by 12, 0.08. Oh, damn it! Yeah, I was off. I don't know why. I thought if I went, I thought I just had to do 4 divided by 12. I don't know exactly why I was wrong. I knew I was going to be wrong, but I just have to move on with life. So that was a pretty good guess, though. 0.084, using whatever logic I just used. So why wasn't it 0.084? Because if I had 12 times 0.084, I'm going to have basically 12 times 8 plus 12 times 0.4. 12 times 0.4, don't know it, but 1.2 is 10% of that. So then times 4 is going to be 4.8. So I'm going to have 96 plus 4.8. So there you go. This was too much. Hell yeah. But yeah, I don't, yeah, that trips me out, where it's just like, whatever logic I was trying to use right here was off, and that's a bummer. I just have to move on with life. I don't see it, and it just seems like I could spend half an hour figuring out why couldn't I just add 4 more, and then realize it, I don't know. Anyway, so now we have an idea of how we're going to guesstimate this area, so let's break out some graph paper and start doing that. Alright, hell yeah. So I can make this I can make it 4 times as big. You know, the dark lines won't match up 100%, but that's alright. I'm going to be okay with that. Let's get it matched up as close as possible. So we're going to have, we're going to go up 8. We're going to go over 8 inches. Alright, up 8 inches. Alright, booyah. I never thought that my compass would not work. So, bummer. I think I do have bigger compasses, though, so we're going to get rid of these ends. There's no reason to have these ends on here if... I don't know. Maybe I can't remove these ends. It wouldn't matter anyway. I wouldn't be able to get up to that. So, let me figure out a way to get a bigger compass. Alright, hell yeah. So, this compass, man, I was able to... This is my other compass. But yeah, I was able to get it to where we can draw an 8-inch circle. So, and I think if I just push this out, yeah, it's maxed out, but I can get it. So I'm just gonna kind of come in here. I'm just gonna kind of measure 8 inches. Get that. Well, I guess I can bring it out, and then use this. Kind of get it in position. There's no way that's... Okay, bummer. I think we can do it though. So I'm going to put it in this corner. I definitely just need to get it kind of juiced up. And we just need from this corner to the other corner. Hey, that's good. That's good enough. Ah, bummer. So why is this too much? I don't know why I stutter so much. I'm going to call myself out on that. Alright, so yeah, that is a bit much. Here we go. Yeah, I think if I just call myself out on the stuttering, and then I think a good thing to do is just stop talking. Booyah. Okay, yeah. So this line is what we want. So, yes, this inside line, we're good to go there. Pretty satisfied. Alright, so now we're going to get down to 4 inches. Alright, sweet. Oh man, bummer. I don't know why that's... I'm sure this graph paper is not like 100% accurate. Alright, so that's gonna... Yeah, I think that's... so hopefully this doesn't overestimate or underestimate. So our line is going to be right here. So I'm just going to kind of darken that in. Anyway, and I'm just going to kind of put some X's on that top line. Cool. Alright, so now what we want to do, well, we need a protractor. So let me pop out, let me get a protractor. Alright, booyah. Now I got like a protractor from Walmart. It was, I think Fiskars, like they make the scissors, but it actually was pretty garbage protractor. Like this one's Westcott. I'm sure it's probably used for, what am I saying? Drafting. I think they make drafting supplies. Could be wrong on that, but. Alright, so we're going to make these triangles. So we're going to go from here to that point. Booyah. And then same thing over here. Alright, hell yeah. And we're going to have to get the angle of this one as well. But I mean, so why I'm making this video is like, I just don't know how to solve this problem with equations or tricks or anything. So, but I do know how to, you know what I mean? I already solved it from a guessing perspective. Like, I love taking someone's really difficult problem and then just guessing within about 5 or 10% and being like, hey, that's probably good enough. Okay, for this one though, we are going to draw, well, we're going to draw this. We're going to do 2 more lines. Because now we have our triangle, but it's going to make more sense once we do this. Draw this line all the way down. Hell yeah. So now when I look at this, if I find this angle here with my protractor, I'll know, and I know the radius. The radius is 8 inches on this one. The radius on this one is 4 inches. And so I would know the percentage, well, the angle of this, so whatever angle that is, that angle divided by 360. It's always good to figure out what the equations are going to be. That's going to give me the kind of basically the percentage, the fractional whole of the whole thing. You know what I mean? Maybe I have 0.25 that's going to be 25% or a quarter, and so forth. And so once I know that, I'll know and I know the area of a circle. So area of a circle is pi r squared. The radius is 8 inches. So I for sure know the area of this 8-inch circle. Cool. So this times that percentage. I call it, anytime I see like a fraction, I'll just you know, let you know that a fractional whole, I'm just going to call a percentage. So we know the percentage of this wedge of the whole circle. So sweet. So then we would know the area of this wedge. We can easily know the area of half the wedge just by dividing by 2, and so then we have the area of half the wedge. But because I know this angle and this is 8 inches, I also know that I know the vertical component of this right triangle, and so the sun is shining. So if I know this angle is this angle divided by 2, and I just put sun rays on my angle to shine on the sine component, and so how I do this is I know if this is a right triangle, the hypotenuse is always the larger number, and then the components of the right triangle in the vertical and horizontal direction are a percentage of this 8. So if I said this is 8 and I wanted to know what half, let's say 50% of 8 might be, that'd be 4 inches. If this is 8 inches, does this look like 4 inches? No. If this is 8, this is 4. And then maybe if this is 1, this looks like about 1 inch. So maybe this is 25 to 30% of 8. So this is going to be 8 times 0.3, let's say. And that's going to give me the dimension here. If it was, let's just say it's 0.25. So 8 times 0.25, this is going to give me, am I saying this right? So if this is 8, this is 4, this is 2. I'm sorry. So this is close to 2 inches. So I'm just going to say, hey, this is 2 inches. How do we get that? Well, we take the bigger number, the hypotenuse, and then multiply it by the percentage. And so I need to make a separate video on this, but if I know that this is the sine component, that's going to be 8 sine of the angle. Our angle is going to be theta divided by 2. But this is synonymous with 8 times a percentage, the percentage of the hypotenuse. So we have in this direction. So this, whatever this value is a percentage of the hypotenuse. If this value is 2, then it's 25% of the hypotenuse. And so the sine of the angle gives you that percentage. Need to get the height right there. Once we know this height, we need to know the base of the right triangle. This base is going to be the cosine component. So we have cosine theta divided by 2, and then multiplied by the hypotenuse. So we're going to take that larger number and then multiply it by a percentage, and that's the cosine component. Okay. So hell yeah. And then the area of this triangle is just 1/2 base times height. So we're going to have 1/2 base is going to be 8 cosine theta divided by 2 times the height, which is 8 sine theta divided by 2. Okay, hell yeah. And so that's going to give us this area of this triangle. Try a new battery, back at it. Alright, this pen kind of works pretty good. It's pretty thin though. Alright, so once we know the area of this triangle, hell yeah, that's going to be the equation for that. And we know the area of the segment. Again, the area of the segment is the area of this whole circle times the percentage of this wedge. You know what I mean? So that's going to be this angle theta divided by 2. So we have the area theta divided by, this angle theta divided by 360. So we have the area of the full circle, theta divided by 360. That's the area of this wedge. We're going to divide that by 2. That's the area of one of these wedges. Or this wedge right here. We're going to subtract this triangle. So we're going to subtract that component, and that leaves us with that slice. So that leaves us with that slice. We're going to multiply by 2 to get the other slice. So sweet. So that's basically our equation for that chunk. And so we can do the same thing over here. I can say, hey, let's find the angle phi of this whole thing. And I know this angle is going to be phi divided by 2. This is going to be 4 cosine phi divided by 2. This vertical segment is going to be 4 sine phi divided by 2. The area of this triangle right here is going to be the base, 4 cosine phi divided by 2, multiplied by the, it's going to be 1/2 base times height, so there's the half. So we have half base, and then the height is 4 sine phi divided by 2. So that's the area of this. We know the area of this wedge because we're going to say, hey, we know the area of a 4-inch circle. And we're going to take that phi divided by 2 divided by 360. I'm just sorry. So this phi is the segment right here. We're going to divide that by 360. That's going to be the percentage, or kind of the fractional whole of that total area of a 4-inch circle. That's going to give us that area. So we're taking the area of a 4-inch circle and then multiplying it by, either a quarter, or in this case it looks like about an eighth, a little more than an eighth of the full circle. So we would have area times 0.125. So that's kind of what, if we wanted to double check what this answer would be. Now this one looks like a 12th. So this is going to be, the area of this is going to be the area of an 8-inch circle times what did we say a 12th was? 0.08. This one's going to be about 0.125. Cool. So just numbers that you could also kind of double check. So once we get the area of this thing, we're going to divide that by 2. And then we get the area of one of these. We're going to subtract then the area of that triangle. That's going to give us one of these. So it's going to give us that area right there. We'd have to then multiply by 2 to get the full thing. Okay, so sweet. So that is what we're going to do. I'm just going to take little half sheets of paper because we're going to, and now we're going to do it. So we're going to get our protractor right here. Yeah, this seems like a pretty nice one. I'm digging this. The angle. I guess 2 ways to do it. It makes more sense. I'm sure it's going to be way more accurate just to throw this right on the origin, zero that out. And then this is going to be 30, what is this, 20, this is 5, 26, 27, 27.5. So this angle is 27.5. Let's come up to here. But the reason I like doing problems this way is because I'm not stressed at all. I have a genuine 100% assurity that I can solve this problem. But even right there, if this is your first rodeo of being like, oh, I didn't even see that, I could take this segment and then subtract one of these triangles. But that's still very basic, using right triangles and knowing how right triangles compare to circles. And then what I'm hoping for on this problem is by the time I get done solving it this way, my brain might just click to be like, oh, no, duh. Obviously I'd want to do it the easier way. But until you start doing it the harder way, your brain's not going to let you do it the easier way because it doesn't know how anyway. Okay, let's try to get too accurate. All right, so we have 10, 20, 30, 40, 50, less than 60, more than 55. So we got 55, 56. So sweet. So this angle right here is going to be 56 degrees. Cool. So we have 56 degrees. Half of that is going to be 25 plus 3. So this is going to be 28 degrees. This one is going to be, I don't know what 27.5 is. How about 28? That's even tough for me. That's going to be 10 plus 4, so that's 14. Cool, and then 14 but minus 0.25, right? So it's going to be 13.75. 13.75, and even this one, I have to double check. But even double checking, it helps your quick skills. We got a 10, we got a 15, and I can just see we're just setty spaghetti. So we have 27. All right, hell yeah. Let's see. Okay, so now we need to know the area. Yeah, how was I going to do this? Those are the only angles I need. So now we're just set. So I'm just going to take my little sheet of paper. We'll kind of make it small, just so we can. All right. So what are we going to do? Should we do this? Now for sure, I just want to use my calculator on this. I'm going to get the area of let's at least show you what we're doing. So we have the area of the 8-inch circle is pi r squared. That's going to be pi 8 squared. That's going to be pi 64. Cool. And then we have 27.5. So 27.5 divided by 360. Yeah, and if we're doing mental math, this is about 30. Let's say this is 36 divided by 360. That's going to be a 10%. But I know this is less. So, yeah, we're right in that 0.08. We're 1/12. That's what we thought. 10% would be 1/10 of a circle. We thought it was 1/12. This number gets bigger. So yes. And if it was, let's say it was, let's say this was 0.05 and it was 5%. Then this would have to be 18 divided by 360. It's not. So what's halfway between 18 and 36? I know there's going to be 8. So it's going to be 18 plus 9. That's going to be 27. Oh, sweet. So right now I just know that the answer is going to be halfway between 5% and 10%. So that's going to be 7.5%. And it's going to be a little bit more than that. So I'm going to say 7.7%, and now I'm going to go for my calculator. So after all that, 27.5 divided by 360, I get 0.076, and hell yeah, my guess was pretty damn good. So sweet. I'm going to store that as I don't know, A. Who cares? But anyway, so we have 7% of the total area of the circle is this segment. We want to divide that by 2 to get this segment. So let's throw in this. So let's go. I'm actually gonna this percentage. What should I store that as? I'm just gonna store it as B. Cool. The area of this circle is going to be pi times 8 squared. I'm going to store that as alpha A. Now, does that make sense? Even just that, the area of an 8-inch circle, is this going to be correct? Well, let's figure it out, because if I have a if this is 8 and this is 8, well, it's part of a circle like that. So let's just say, hey, this is 16 by 16. So 16 times 16 is going to be the area of this square. I can't even do that, but I'm pretty good at this. So this is 10 times 10. That's 100. This is 6 times 10 plus 6 times 10. That's another 120. And then it's 6 times 6 is 36. So we have 256. So sweet. So is 201 pretty close? Hell yeah, because the area of this, it's about 70%. So or it's about 70 to 80%. So then even, how do I do that? 0.7 or 0.8%. Like I said, this might be where the gold is on some of my videos. If people don't want me to use the calculator, like this is the restaurant method. What's 70% or 80% of 256? I don't know, but I do know what 10% is. That's going to be 25.6. Sweet. So what's 20%? Let's just work with 25. So 20% is 50. Okay. So 40% is 100. That's holy hell. Yeah. So 20% is 50 times 4. It would be 80. All right. Sorry about that. Camera ran out of juice, but yeah, we didn't get too far. So yeah. So I have to go back over this. We're trying to find 80% of 256. 10% is basically 25. Cool. So if 10% is 25, what's 20%? That's going to be 50. Cool, that's 20%. What's 80%? Just 4 times 50. So then I went to 200. And so, yeah, the answer is going to be close to 200. We see it's close to 200. But it's 25.6. So what about this 0.6? You know what I mean? Well, we're going to have to multiply that by 8. So then I did 6 times 8 is 48. I can get there. And or 0.6 times 8. So 0.6 times 8 is 48, but 0.6 times 8 is 4.8. So we're going to have 204.8. And just to show you, 256 times 0.8 is 204.8. Now we're going to do the same thing for 70% of 256. Same thing. What's 10% of 256? Well, basically about 25. All right, so hell yeah. So if 10% of 256 is basically 25, that's going to be 10%. Well, what's 40%? If I just multiply 25 by 4, that gets me to 40%, and that's going to be 100. So that means that 200 is going to be 80%. 70% is going to be minus one of those. So it's going to be 175. So I don't know. Yes, like I'll get better at this, but hell yeah. So 70% of 250 is going to be 175. But we do have to add this 6. So I'll write that in. So we have 175. 6 times 7 is 56, right? Because that's that 5, 6. No. 6 times 7. Yeah, this bums me out. 6 times 7. So here's the trick that I use. I don't know what 6 times 7 is, but I do know what 7 times 3 is. Hell yeah, that's drinking age. 21. So sweet. So, and then it's super easy to do 21 times 2. So that's a check on reality that 6 times 7 is 42. Else, I just go by memory. I definitely, this was one of the original videos that got me into trying to make videos on math, because it's just like, yeah, we all know, maybe most people know 6 times 7 just by memory. Like if you know it's 42, it's probably by memory, not by any other, because these numbers are kind of funky. 6 and then an odd number 7, and they're more than halfway up the digits between 0 and 10, so it gets a little tricky. But hell yeah, just easily divide 6 by 2. And then you're just, you're in. Because that's 3 times 7 is 21, and it's double. So I think that's a pretty easy way to see that. Okay, so 0.6 times 7 is 4.2. So we're going to have 4.2. So this is going to be 179.2. So I think the answer is going to be 179.2 and 204.8. I was just guesstimating, but I think a circle is more than 75%. So that's what I should have done, is what's 0.75 times 256. So let's do that. You know what I mean? We know what 0.7 is. That's 179.2. What's 0.05? What's 5% of 256? Don't know it, but I do know what 10% is. What's half of this? Is that how we do it? Holy hell. Well, yeah, let's work back. So we're saying that 80% is basically 200. 75% is what's 5% of this? So we know what 10% is, so we just need to subtract 5%. So we're basically saying 200 minus half of this, which is, I don't know, 12, 13. And so we're going to have 187. 187. But then the area of a circle is halfway between a third, 3/4, and 100, it's halfway between 80% and 75%. All right, so if we're going to even know what the hell I'm doing. So we have, let's say we have an area of a circle of 1. That's going to be pi r squared. That's going to be pi. That's the area of a circle. But if it's a radius of 1, the side length is going to be 2. And the area would be, the area of the square would be 4. So if we do pi divided by 4, that gives me the fractional percent, which is 0.78. So that's the whole thing going through here, is that if you take a circle, turn it into a square, the circle is going to be 78.5% of the area of the square. So it's not 0.75, it's not 0.7, it's not 0.8, but it's halfway between 0.75 and 0.8. So that's kind of what I remember. And it's good to go through this kind of mental math, because it kind of it clicks. And you might even be able to remember this, that hell yeah, this is called like what? Circumscribing a circle with a square. Then the area of the square, or the area of the circle, will be 78.5% the area of the square that you coated that circle with. All right, that was brutal. I don't even know where the hell we're at, but we just wanted to know. We got the area of this circle. We just wanted to know if we were halfway sane, and that's what we did. We said that this radius is 8. Now, don't confuse radius with diameter, because if this is the radius and you want to draw a square around something, then this side of this, I don't know why I'm stuttering so much, but the side of this square becomes 2 times the radius, or 16. So we're going to have 16 squared, that's 256, but then times 0.785, and we get 194. So 194 should be the area of this circle. Let's try it out. And the area actually comes out to be 102.06. I don't know why the discrepancy there, though. So if we have pi, so alpha pi 8 squared, that's 102.8. And then if we had the circle, so we're going to take that divided by 16 squared. That's 0.785. But I guess it's 78.54%. So if I took this area of 201 multiplied by 0.78, oh, my apologies. If I took 16 squared and then multiplied by 0.7854, that gets me that 201. Okay, so now we have a check on reality. We for sure know that's the area of the full circle. Now this ratio is going to be 27.5 divided by 360. That's our ratio. Is that what we stored as alpha b? Hell yes. So the ratio is stored as alpha b. So we're going to take that area times that ratio. And so the area of this thing is going to be 15.35. I'm going to store that as alpha c. And then half of it's going to be divided by 2. Store that as alpha d. So now the area of this segment with the curve is going to be, I don't even know where to put these. I'm going to call that alpha d. Okay, so now we're going to get the area of this triangle. So I'm going to do 27.5 divided by 2. Store that as this angle theta. In my calculator, I'm just going to store this as theta. Cool. Even though, anyway. So then we have, we can figure out the sine component and the cosine component. And we need, and the area of this triangle is going to be 1/2. So we got 0.5 times the base, which is 8 cosine that angle, times the height, which is 8 sine that angle. Cool, so that's the area of this triangle. I'm going to store it as alpha e. So now I'm going to take alpha d minus alpha e, and then I get this area. So booyah. So I think I did everything right. Now we know the area of here. I'm going to double it, or I'm going to store that as alpha f, double it, store that as alpha g. So then I know that this segment right here, this full segment is alpha g, and we're going to do the same thing over here. So this is where I would rather use a calculator, and a calculator can be more beneficial to figure out what's going on. You don't get carpal tunnel just writing line after line. I do not mind doing this mental math, but to write things out, I think is a mistake. I think it's almost better to use your computational skills with your calculator because you're not able to write it out, so you kind of have to do it by memory. All right, so let's do it. So this angle, what did we say? It was 56. So we're going to have the area of this circle is pi 4 squared. And then we're going to multiply it by 56 divided by 360. So now we know this area right here. So we took the area of the 4-inch circle. And we could just double check. That's 8 times 8. 8 squared. This area of this circle should be about, well, 0.75 times 64. And so I did that wrong. Anyway, so the area of this circle is this. And then if we had 4 times 2 squared times 0.785, 4. Cool. No, 0.7854. The area should be 50.26. And this is good. I really love to memorize decimals. So now I know 0.7854. You know, I thought it was halfway between, and what's halfway between 0.8? So I'd do 0.8 plus 0.75 divided by 2. That's the halfway point. It's more than halfway, though. So it's definitely more than halfway. Is it a 3/4 of the way? So now I'm going to add 0.8 divided by 2. And it is. It's almost 3/4 of the way between 0.75 and 0.8. Yeah, so that's good reference, and it's 0.7854, which is about 3/4 of the way between 0.75 and, so on a number line, if this is 0.75 and this is 0.8, this is 0.775, and this is 3/4, 0.7, I don't even know what the hell 3/4 was, 0.7875, and what we want is 0.7854. So it's just less than 3/4. So now you know, it's really good to know your conversions, to be like, hey, if I have a circle inscribed within a square, what's the area compared to the area of the square? It's going to be 78.54, of that area of the square. Okay, booyah. So let's go back to this. So we have 4 pi squared. Whoa, whoa, whoa. 4 pi... 4 pi, oh, no, it's pi r squared. Pi 4 squared, area of this circle, multiplied by the angle here is 56, divided by the total circle. That's the fractional whole. So this is the area of that. Cool. And now I'm going to divide by 2, get the area of one of these. I'm going to store that as alpha I. So that's the area of this segment with the curve. I'm going to find the area of the triangle. That's going to be 0.5 times 4. So the base is cosine, 4 cosine 28. Just make sure we're in degrees. So we have 1/2 base times the height is going to be 4 sine 28. Hell yeah. And I'm going to store that as alpha j. So alpha I, the area of this whole triangle with the curve, is 3.8. Alpha j is 3.3. So yes, I have a check on reality that those are, I didn't make any mistakes. So we have alpha j minus alpha I. Alpha I is the area with the curve minus the triangle alpha j. That's going to give me this part multiplied by 2. Now it's both parts. And I'm going to store that. If this was g, I'm going to store that as h. Store that as alpha h. Sweet. So now we have alpha g plus alpha h. We have the area of this. It's 1 point... oh, do we have this right? 1.7. I feel like that is horrid. Why didn't this area come out right? Alpha g is 0.5. Alpha h is 1.18. Is my units wrong? Oh, no, duh. No, that's the actual area of this. We changed our problem around where this is 4, this is 8. So hell yeah, our answer is only relative to this problem. So yes. So we have alpha g plus alpha h stored as alpha. I'll store it as alpha m. So our answer for this, the area of that is 1.769 inches squared. And is that about true? You know what I mean? Because if I break out my ruler, hey, this is 3/8. So that's 3/8 even just right there. 3/8 of an inch. And even if I underestimated this, made this a triangle, this part, well, let's just say it's 2. So we have 2 times 3/8. And we're going to have 2 of those. So I can just say 3/8 times 2 is the area of that rectangle. So we have 3 divided by 8 times 2. So that area is going to be 0.75. How the hell? Now I'm just freaking out. So we have this. This is... yeah, I don't know why I'm freaking out. Maybe... 3/8 times 2. Oh, I'm sorry. It's not 3/8 at all. This is 3/4. So there you go. So 3/4 times 2 is 1.5. The answer undershot is 1.5. Our answer is 1.7. Yeah, sometimes even just guessing, you'll do stuff wrong like that. But it's better to do stuff wrong when you guess than actually, miss a factor of 2 in your problem. That happens all the time where you have to divide something by 2. Alright, hell yeah. So now I think this actually might be kind of tricky. What we're going to do is try to get an equation, because I don't even know how to scale this back to our problem that just had 2L and L right here. This radius was L, and this radius was 2L. But what I can do is at least we have these angles, so we can just go back through and figure out exactly what we did. It's also a good skill to be like, hey, could you write out the answer for this just all in one go? So the answer to this is going to be, we're going to have 2 of these segments. So kind of working back, it's always a good idea to work to find how to work back. We're gonna work with this segment first. So I'm gonna say we have 2 of them. So 2 times 1 of those. One of these is going to be so we have 2 times. We need to find the area of this segment, which is, and I'm going to say that this is just 2L, and then L in our case is going to be 4 inches. So the area, the full area of the circle is going to be pi 2L squared. And then we're going to, so that's the area of the whole thing. We know, and then we know the angle here is going to be, because this angle is going to be the same. It doesn't matter, this angle is always going to be, and it's interesting, is 56 divided by 2 is 28. So even just right there is like, I see a correlation between these angles. This one's 56 and this one's basically 28. So if this one is 56, let's just make this one 28. And we'll make this 14. So that's one aspect. So that's what I was saying, is just like when you do these problems, you might run across something that you're just like, oh, well, that's probably where the simplified, it's just like, how do we know that? How did we know that if we double, if I have a triangle right here, and then I double the length? I don't think that's true, though. I don't think if I have a 30-degree triangle, and I just double this length, that I have a 15-degree triangle. It doesn't work like that. So maybe I'm going to still stick with 27.5. But that it is close. Half of 56 is 28, which we have right here. So this 28. Anyway, but I don't know if that's going to be exact. But yeah, that is, we would have, well, but no, in that case you aren't. So let's take a look at that. I said if you had a 30-degree triangle right here, and we knew this was 0.866, and I doubled this to another 0.866, and then did this angle. This angle is not 15 degrees. I just kind of know that, because then, I mean, if I kept increasing it, you don't reduce by half every time. You know what I mean? If I double this distance, I don't reduce by it. Maybe you do. You know what I mean? I don't think so. I can just do that right now in my calculator. So if I have a triangle that's, so this would be the inverse tangent of 0.5 divided by 0.866 times 2. And the angle right here is, well, what the hell? The angle would be 0.5, oh, sorry, order of operations. 16. So yes, it's not 15, it's 16. But let's do this. Let's say this triangle has a 1, and this one has 2. So we got 0.5, and this is 0.866. So now, what is this angle? This angle is, and the fast way to find the angle is just say, hey, this is the sine component of the angle. Sun is shining on the sine. I know the sine and the hypotenuse. Sweet. Inverse sine must be the inverse sine of the opposite divided by the hypotenuse is the angle. So we can do inverse sine of 0.5 divided by 2, and this gives me 14.47. So again, that's not half of 30. So we checked it both ways, and there is nothing fancy there. It's close. It's a close approximation of this angle is twice this angle, but it's not 100%. So moving on to the actual answer. So I want to know, I know I'm going to have 2 of these. So 2, I need to figure out what one of them is. It's the angle of this, which is the angle of the whole circle, pi 2L squared. Minus, well, no, times the percentage, so that's the area of the whole thing. The area of just this thing is this angle, which is, in our case, 27.5, divided by 360. Cool, so that's the percentage of the whole area of the circle. That's this slice. We're going to divide that by 2. So I'm just going to do 1/2 out there. That's where this divide by 2. So that's going to be the area of this plus that, curved part. Now we're going to subtract the area of the triangle. That's going to be 1/2. So now this 1/2 drops out, so we can easily just see that. But 1/2 base, which is, this is 2L. 2L cosine of the angle, which is, now the angle is 27.5 divided by 2. So I'll do 27.5 divided by 2 times, so it's 1/2 base times height, and that's going to be, the height is 2L sine 27.5 divided by 2. Okay, hell yeah. So this simplifies to pi 2L squared times 27.5 360 minus, now this becomes 2L squared cosine 27.5 2, and then sine 27.5 2. Alright, booyah. So there you go. And you could factor out a 2L if you wanted to, which we do because we wanted to figure out what the area is in terms of L. And this is going to give us the area of that thing in terms of L. So we're going to have area is 2L squared, which, we should factor out the, I don't know, how much more do we need to do? And then we're going to, and then that's just this segment. We need to add it to the other two segments. And then we would get an area in terms of everything in terms of L. So sweet. So then, then we're just set. Okay. Let's hold off on factoring this, and let's get the other term. The other term of this area, just from here, is going to be pi L squared. And then the angle there is going to be 56. 56 divided by 360 minus L squared cosine 56 divided by 2 sine 56 divided by 2. Alright, sorry for just writing pretty sloppy. But, okay, so now we're set. So now we can kind of start simplifying this. Yeah. I don't know. Now let's get L on its own. So we're going to factor out the L squared of all of these, because we're going to add these together. They all have an L squared term. This is just 4L squared. So let's make this 4L squared, and now we can factor out the L squared. So we have L squared factored out, and then whatever is in here, now we're just going to be set. So we're going to have 4 pi 27.5 360 minus 4 cosine 27.5 divided by 2 sine 27.5 divided by 2. See, that's why I don't mind just scratching this stuff out, because we've already gone over, we've already exactly know what it means, you know what I mean? So, and then it's very useful to be like, hey, do you see this? This whole component was the area of the triangle, which was 1/2 base, this is base, times height. And even sine and cosine, what does that mean? That's percentages. This whole thing is a percentage, and then you're multiplying the percentage of the hypotenuse. Well, that was this term right out here, this L squared, which we, which the 2L was the hypotenuse, and we had 2 of those because we had to do the hypotenuse times the percent, hypotenuse times the percent. So it's always good to go back through your equations and then, explain to yourself what was going on. So this was the percentage, this was the hypotenuse. So there you go. And then this was the coefficient, you know what I mean? Because we had 2L. So this is 2 times 2. So there you go. So 2 times the hypotenuse times the percent is the base. 2 times the hypotenuse times the percent is the height. The half we got rid of a long time ago because we're going to have 2 of those segments anyway. Yep. And yes. Okay, hell yeah. All right, so moving on, and so that was that first term. Well, I guess we're factoring out L squared out of everything. So we have this segment of the area minus the triangle, and then we have this segment of the area, which is, let's see what that is. So that's going to be, and in both of these we had the area of the full segment using that, that larger angle, 27.5. Here it was 56. This larger angle was the angle of that, and then you got the percentage of, whatever this area was compared to the full circle, that was due to 56 divided by 360, to explain that in words. But once we figured out this area, we needed to half that. And so that's where this half comes in on both terms. And then we factor that out. So I guess I just didn't show you to factor it out on this second term. But we're going to have the area of is going to be pi L squared. But we're not going to have this 4, so we're just going to have pi 56 divided by 360. But yeah, I could make a horrible error here. So minus pi 56. So I could double check. That's why this is 4 pi, because we had 2L. So the area of this, the area of the full circle was pi r squared. So it's 2L squared. So that's going to be 4 pi L squared, or pi 4L squared. And the area of this circle is just going to be pi L squared. The radius is L, so the area is pi r squared, pi L squared. Hell yeah. And then multiplied by the percentage of this full circle, and then you have to divide by 2 to just key in on that area. Hell yeah. All right, hell yeah. So I like this idea of just like talking your way through it. I think that's where, I don't know, I think that's where my videos shine, even though, I don't know. I guess, I don't know. Yep. I see if I keep doing this, though, I'll find better ways to be better. And I just want to be better for myself, but I guess that rubs off on being better all around. All right. But this whole juggling is just like, well, I probably should have wrote more, because right now I'm just like kind of freaking out. So we have pi. So, but it's good. We have an equation. We're going to do the same thing. Can we explain where this comes from? So we have pi radius squared, because we factored out the L2 over every term. So I see, and why is this negative? This shouldn't be negative at all. Yeah. So we have, so we're taking the area of this, subtracting the area of the triangle. So this is the area of this shape subtracted by the area of this shape. So same thing, we have the area of now kind of the bigger one, and it's a combination of 2 of these, but we're just taking the area of the top one because we already factored out, again, we already factored out this half. Because in the end, we're just going to take the area of this subtracted by the triangle. That only leaves this chunk. But that's not there's 2 of those. So that's what I did right at the beginning. So hell yeah. All right, so we have pi r squared times 56 divided by 360. That is the area now of just this chunk, because we already factored out the 1/2. Anyway, all right, so now we're going to subtract the triangle. The triangle is that 1/2 base times height, but we already factored that out. Or we needed to double it anyway. So the fact that, oh, that's right. So now I'm working on this area, we only needed half, but in the end we had to double it anyway. So that's where it is. So mentally, I'm finding the area here. But then I'm saying I only need half of it to figure out this area subtracted by the triangle. but that results only in this portion, and I need to double it anyway. So now I'm just going to take this whole area, but then subtract it by, instead of 1/2 base times height, I'm taking, yeah, there you go. So that mentally and visually explains it. I'm taking this whole area, and instead of subtracting 1/2 base times height, this triangle, I'm just subtracting the whole rectangle, base times height, which is this, but that's these two rectangles. So the area of this ice cream cone subtracted by this. And I'm sure there's just an easy equation to be like, yeah, no duh. You're going to take the area of this ice cream cone and then subtract base times height and be done. Not 1/2, you know what I mean? Because this will be a representative triangle. So these two triangles are the same as these two triangles. So there you go. All right. All right, we're going to run out of juice, but okay, so instead of doing 1/2 base times height, I fully explained that now. We have the area of this triangle, pi r squared, and then 56 divided by 360, that's the percentage of that full circle. That's just right here. That's the area right there. Subtracting base times height, which is the representative rectangle, or both of those areas. And that's going to be base is going to be... so now why up here do I only have 4? Oh, never mind. That was 2L. We had 2L, and yes, this was 2 times 2, and this was L times squared. But right here, I just have my base is L. So we're factoring out the 2L, but let's rewrite this again. So my base right here is going to be L, the radius, cosine of the angle divided by 2. And then we have L sine angle divided by 2. Hell yeah. And then I factored out the L squared, so we just have cosine angle divided by 2, sine angle divided by 2. So I don't have this coefficient here of 4. I just have a coefficient of 1. So I have subtract cosine 56 divided by 2, sine 56 divided by 2. And I like writing just totally crap. Well, it keeps my... if I write too intense, I have stress issues where my hands will just fall apart. I'm more interested in using my voice to explain things and just having the writing on the page just kind of back it up a little bit. But yeah, I don't mind writing over things. I think it's more in the actual understanding of what's going on. And that's where it's just like, I'll always pause. If I can't understand what's going on, then we'll rework it. And if I do know what's going on, I use this idea of juggling. You know what I mean? I can only like juggle one item at a time, and sometimes you have to go back to just like, hey, you know, starting from, that's why I always go back and kind of work my way through it, and then you get to kind of do that about 5 or 10 times until it's just kind of like, hey, we know exactly what the hell we just did. And then so when we get an equation like this, we could pick out what's going on, and hopefully that's going to reduce the chance of making mistakes. But now this is just a big old constant. We're going to have a big old constant times L squared, and now I'm going to figure out what that constant is. And we're going to double check because we just said alpha m when L is 4 inches. If L is 4 inches, this total area is 1.76. So now I can just even estimate what this constant is from that. I can say 1.76 is equal to this constant times 4 inches squared. So I'm going to do this divided by 4 squared. This constant has to be about 0.11. Cool. So let's now throw this into our calculator and see if that's the case. We have 4 pi 27.5 divided by 360. So here's where I'm at. Minus 4 cosine 27.5 divided by 2. But again, like all we're doing is like the total guess and check method. The way we got these angles was just from just graphing it. I mean, just drawing it in, and I bet you we're pretty close. We're within 5%. We're probably within 3% error. Okay, hell yeah. Sine 27.5. But I'm bummed that it's just like the next method to actually figure out what these angles are. I don't know if I have an approach that I can do within you know, an hour or two. So we might be done with this video, and I might have to divvy this video up into two. Yeah, because this will be pretty. Once we get this, you'll be like, hell yeah, yeah. This will double check our answer. All right, moving on. Plus pi 56 divided by 360 minus cosine 56 divided by 2 sine 56 divided by 2. All right, hell yeah. And check it out. See, that's where the confidence level, like, if this was wrong, I wouldn't have mattered because we would have found our error. But hell yeah, you know, just doubling down on being like, hey, well, isn't this what we should have got? So the second you actually plug that number in and put enter, you know what I mean? Back it up to be like, hey, are you confident of the number that's going to show up? Is that going to mean anything to you? And so hell yeah. So now we know the area of that. So we know the area, so we can just say for this problem and for this video, because I think I'm done. Like I could stop stuttering, and then stop talking, and then yeah, I'm trying to work on the stuttering. Damn. All right, so the area of that shaded region is 0.1106 L squared. Cool. I'm going to store that as x, because if we have x times 4 squared, we get that 1.769 that we, yes, there you go. And, I don't know. Let's say I squared that number, doesn't mean nothing. Let's say I took this, say I took the square root of that number, don't mean nothing. All right, so, but there you go. The other way that I want to do this is just get an equation for this, get an equation for this, and then I guess, I don't know, I was thinking, I don't know. Yeah, that for that video, even if I got those locations, cool, then what? I could figure out this length. Yeah, okay, so let's talk, for this next video, I was just like, well, if I knew the equation of this line and the equation of that line, I could figure out these 2 points by making the equations equivalent or equal to each other. And if I knew these equations, the x coordinate, xy coordinate, let's call that x1, y1, x2, y2, then I would know the length of this line. So I could figure that out. And if I knew the length of this line, does that help me at all? I don't know. Oh, that's interesting. Well, anyway, so for that problem, I just don't know how much. I want to figure out a same method. Like, hey, figure out a way that I just know for sure I can grind out the answer. But doing it this way, I'm just not quite sure. And it's not even the simplest way to do it. It's still, that would be a hell of a complicated way. And I'm kind of bummed I just don't see the magic trick of, you know, adding and subtracting these and getting that area. I don't see it. So anyway, so I'm going to be done with this. So thanks for joining me. This was using kind of a graphical solution just to get you, you know, all this did is just like, hell yeah, this kind of double checks our answer. So any other method that we use that's more complicated or even simpler that tries to get an answer to this problem, we can at least double check it to a solution that I'm 99.9% is pretty darn accurate. So, you know, just going through the logic that we went through. All right, so hell yeah. So thanks for joining me on this one, and guess what? That's a video. All right, hell yeah. So we have Professor Pavi's perplexing problems. Now, this one is where you have 2 circles inside a square. This one has a radius of 2L, and then this has a radius of basically half the side of the square. And so what we want to know is the shaded region. And this is so cool because I thought there was some sort of trick where you just kind of added this one and subtracted that one and figured out the area. And then, you know what I mean? I thought it was that type of problem. But then I was just like, you know what? We're going to throw in the towel and see if just what I know about geometry is going to solve this. And I've I love problems that involve whatever that's called, like where you have a chord on a circle, because you know that bisecting it, I don't know, it's just going to be right down the middle, and then you're going to get these right triangles. And so you have to use, this wedge, which is going to be, hey, this angle, and if we have this wedge, that the area of this is going to be kind of this ice cream cone, shape, where you actually kind of have this curved part on top. And so what we can do is we can find the area of just that section by taking the area of this wedge and then subtracting these two triangles. So that's what we did. And for the problem, what I did was I just drew it out. I was like, hell yeah, let's just draw to scale, however you want to see this. But yeah, let's just draw to scale, this square as big as possible. And then we estimated the area, and then what we did for estimation is I estimated this angle. That was the only part of the problem where I'm just like, I don't see it. I don't see how you actually figure out this angle. But then I was just like, well, going through it, I bet you I could have a way to find that. And I still haven't solved the problem 100%, but going through that whole process and getting an answer for this based on just estimating that this angle was about 27.5, now from there to there, and then this angle from there to there was 56 degrees. So just using that, then I'll go through, hopefully in just kind of a 5-minute process, go through the answer that I got. But then I was just like, the one thing that I did see is just like, whoa, we have, because these two right triangles have a common side, this is going to be the same as that. So, okay, so let's walk through the full solution. So I'm just gonna work on one segment at a time. So this whole circle is going to have an area of just pi r squared. Cool. And so how would we know, and that's the area of this circle, then we need to know, what the area of this part of a circle, you know what I mean? If I mentioned in the video that if this part is like a 90-degree angle, well, it's going to be a quarter of the circle. I see that it's about a 1/12 of the circle, but how do we find that? That's where I totally just had to guesstimate or use my protractor and say, hey, this angle right here was going to be about 27.5 degrees. Okay, so if I know a full circle is 360 and I have 27.5 divided by 360, and so that's this equation right here. If I have pi r squared, and then the angle 27.5 divided by 360. That gives me the area of this. Okay, so then I say a half of that is the area of this, and then I subtract out this right triangle, which is 1/2 base times height. And if I know that this angle is, 27.5 divided by 2, hell yeah, then I know that this is the sine component, this is the cosine component. The hypotenuse is just 2L. So then that component right there is going to be 1/2, the area of a triangle, base. The base is 2L cosine theta divided by 2 times 2L sine theta divided by 2. And I'm sorry, it's this one up here. So we have the base is 1/2 2L cosine theta divided by 2 times 2L sine theta divided by 2. I just brought this. So I started with the generic equation that the area of this triangle is 1/2 base, which is the hypotenuse times the cosine of the angle. And in the video, I really strongly suggest understanding that sines and cosines are percentages of the hypotenuse. So if you can see that this is just the hypotenuse times the percentage in that cosine direction, hypotenuse percentage in the sine direction. So that's where those come from. I can see that the hypotenuse is just the radius. I can bring those out front, r squared, and so that's what I do. The radius is 2L squared, so we're going to have a 4 term on this one. And so, just for, if I'm just doing a straight equation, let's now figure out what the area of this little chunk is. So we're going to have the area of this is going to be, well, first we're going to take pi r squared, which is pi times 4l squared. Cool. And then we're going to multiply it by the percentage of the full circle. That's going to be theta divided by 360. We're going to half it. That's where this half comes in. That's the area of this shape with the curve. Then we're going to subtract out the triangle, which is 1/2 base times height. And then we just showed that's going to be 2L cosine theta divided by 2 times 2L sine theta divided by 2. So we get 4L squared. And we have this half term. Now that is just the area of this little chunk right here. So we do need to double this if we want both those areas. So then the full equation, and then, okay, so that's just the chunk on this side, and then we can do that same process with this triangle. We can say, hey, what's the area of this? Well, that's the area of this circle, which is pi r squared. The radius is L, so it's pi L squared. Cool. And then we have a percentage, which is this angle divided by 360. So where do I have that one? That one's going to be the second triangle. So I have 1/2. So I have pi L squared. That's the radius of that circle. Times phi divided by 360. I'm going to call this angle phi. And so that's the percentage of the full circle. So that's this whole area. But then I'm just going to say, hey, I just need half of it with this curve, and then I'm going to subtract out that triangle. So I'm going to take this and then subtract out the triangle. And so it's the same process that we did for this one. I just didn't show the full equation on that. Well, I guess let's talk our way through it. So we're going to have this area 1/2 pi L squared phi divided by 360. That's this full chunk. Then we're going to subtract out 1/2. The base is going to be, we're going to have base times height. The base is the radius, L cosine phi divided by 2. Now, I should have that one. Yeah, so we have 1/2 L cosine phi divided by 2 times the height is L sine phi divided by 2. I just brought both these L's to the front. But sometimes, I shouldn't have done that, you know what I mean? It's better to actually put these L's where you would have them. You'd have 1/2 base times height. So one of these L's, you know, we have L. So like one of these L's, so that's the base. And then the other L in that term is the height. So, yeah, shame on me, because sometimes I don't like when people simplify equations because they're not in the form that you would actually visually see, you know, 1/2 base times height. Okay, so hell yeah. So that's that triangle, and then we're going to subtract it from this one, which was pi L squared times that percentage, phi divided by 360, and then half of it. So we take this and then subtract that. Cool. And then when we do that, we always have an L over 2 term. So we get something like this. And sorry, that's where I'm going to kind of end this part of the video. So, and then we're going to get like 0.11 L squared. And so that's basically the answer. But this answer came from the fact that I visually, you know, visually got this angle. I didn't get this angle from equation. I didn't get this angle from the equation. So then the next part of this video is just like, well, hell yeah, let's do that. Let's figure out if we can actually find these. But this problem tripped me up because I swear it was like, you ever watch Die Hard with a Vengeance and you have like a 3-gallon and a 3-gallon and a 5-gallon jug of water, and you need to make 4 gallons. I swear I thought this problem was like that, you know what I mean? Where, and I think that is the trick of like, you know, what do you do, you know what I mean, to get 4? 6 minus 5 times 4. You can just do that. Look at the little equation. Just do 2 of these minus 1 of those, and then do that 4 times. Anyway, But I totally thought that was the idea behind this, and it's just like, nah, let's go back to the drawing board. And this is cool because this is my style of like, if I had to do this whole problem analytically, I would. You know what I mean? Like, just because, let's say you don't know what the hell a sine or a cosine is, and you don't know that, hey, you take this hypotenuse and then multiply it by the cosine of this angle once you know that angle, and that's going to be this length. Just measure it. I set up this problem where the hypotenuse right here was 8 inches and the hypotenuse right here for L was 4 inches. Well, I could have just so if this is 8 inches, like what I could have done is just like, well, hell yeah, let's just measure this cosine component. And I'm going to say it's about 7 3/4, you know, and then get on with life. And then I'm going to say, you know, what is this? This component, this vertical component, looks like 1 7/8. And just, that's it. You know what I mean? So I really do enjoy graphical methods, and I'll probably be doing more. But it's like, anytime you have a hard problem, sure, you want to do like, maybe like the trickiest trick to get there the fastest. Second is just, hey, let's figure out if we can have an equation that actually makes sense. And equations are cool because they show you logically that you can get to an answer that's like going to be, totally correct and very accurate, and that's pretty cool too. But if you're not knowing the trick or not even seeing the equations that can be made, then for sure, like, if there's a part of it that's tricky, just estimate it, you know what I mean? And then, and especially for this one, there was a lot about trigonometry that I did know. I had no idea how I was going to get this angle in a simplified way. I was thinking of like getting an equation for this circle, getting an equation for this circle, and then maybe, and I still want to do that. I really want to overcomplicate this problem and use two equations, make them and find these points, the x and y coordinates of these 2 points, and see if I can, and then also, maybe integration only gives you the area under the curve, but then also there is an equation where you can actually get arc length, you know what I mean? So if I want to know this length between these 2 points, that is the other aspect. So that sounds very techy. But anyway, so I'm going to go back and see if just the fact that these are linked up, doesn't that give me a relationship? It gives me a relationship, yeah, even just right now. And that's where I just need to get better, is just like, what does this mean? Like, just as an equation, so let's write this down and slow down. If I have L sine phi divided by 2 is equal to 2L sine theta divided by 2, this gives me, it doesn't give me what one, this is just one equation with 2 unknowns, but it still gives me the ratio, you know what I mean? Let's say, it just gives you a ratio. So if I know that phi is 56, it's going to say that theta is, it's not quite half. If this was 28, so theta is going to be 0.4, maybe 0.495. There you go. So if so we have phi is equal to, we would have theta. So this theta is going to be 0.495 times phi. So there you go. And let's see if that would even, 0.495 times 27.5 is, 0.495 times 56 is 27.7. So hell yeah, it's like, and even just right there, it's just like, well, I'm just guessing, but how would you do that? So what I would say is I have 56 is equal to 27.5 times this, conversion factor. So we have k. So k is going to be 56 divided by 27.5. And so there you go. So it's a factor of 2, or it's a factor of 0.49107. And so 2.036. So even when I actually, and then we can just do that right now. This is just so fascinating to me. And that was the whole idea of running through this problem. Now, after I get done kind of with my short version, this is taking about 20 minutes. I'll show you the full, you'll see the full footage of me, just going through the motions, just saying, hey, I throw in the towel. I don't know how to do this from a technical standpoint, but we're still going to get an answer. All right, our battery's running almost dead, so let's finish up quickly. Okay, booyah. So we can cancel out the L's, and we have sine, and we can cancel out the 2. So we have, no, we can't cancel out the 2. We have phi 2 is equal to sine theta 2. All right, so now we can just do inverse sine on both sides. So if we, does that even work? Holy hell, no. I can cancel out the L. We have, all right, hell yeah. Sorry about that. We got a new battery, and I need to slow down. But I technically don't, because we already kind of know the answer. You know what I mean? It's so cool, like when you get equations and you're kind of simplifying, where you already kind of like, yeah, you already kind of basically got the ratio figured out. But here we go. So we're going to have sine phi divided by 2 is equal to 2 sine theta divided by 2. So now, what the hell do we do with this 2? I think we have to keep the 2 over there. Now, yeah, what do we do here? I really don't even know. Can I take? All right. So now I actually need to. I don't know. Can I, if I take the inverse sine of both sides? What the hell is the inverse sine of 2? You know what I mean? Can I don't think I can just pop that out like that. So I have to throw in the towel right now. Catch you on the flip side. Alright, hell yeah. I don't know what I'm doing, but this is a good place to, you know, put my time and effort. Because it gets like, what the hell is sine? So we have sine of an angle. I always do like a 30-degree angle because it just kind of helps you out. So if I say sine of 30, well, I know that's 0.5. And what the hell does that mean? Well, it means that, you know, I always do like a hypotenuse of 1, kind of a unit triangle of 30. So sine of 30 means that I'm going to have 0.5. Anytime that you have, you know, something like this where you get sine of 30, just divide it by 1 because it is a ratio. It's saying that this opposite side is 0.5, the hypotenuse is 1. So here I'm going to say if I have a, so what we have here is we have a fat triangle and then kind of a skinnier triangle. This is phi, this is theta, so that's kind of what we have going on. We're looking at these two triangles, and cool. And so, and do I just have this written wrong or something? Like, let's go back to, like, what is, yeah, this is the hypotenuse, 2L. Sine phi divided by 2. And this is just L sine theta divided by 2. Yeah, so this is a hypotenuse of 1. This has a hypotenuse of 2. Cool. So I'm just going to say the actual length of this one. What should we say? I'm just going to call this length phi prime and this length theta prime. Or I'm going to say phi bar and then theta bar. So it's the actual line segment related to phi, and that's going to be the vertical one. And that kind of, at least, I think that'll be helpful. So now we have, so the generic on this will be phi bar sine, the angle phi divided by 2 is equal to theta bar sine theta divided by 2. Because what I want to say is, what is sine theta? So if I have sine theta is going to be, oh bummer man, it's tripping me out because like these bars look horizontal, but we're talking about the sine component. This is the vertical component. Cool. Okay. But yeah, what is sine? It's the sine is the vertical component divided by the hypotenuse. So this term right here is, and then we're going to say this angle is theta divided by 2. This angle's theta. So even just right there, I can get. I don't have to be bothered by this theta 2. But okay. So what is sine of this angle theta divided by 2? That is going to be this opposite. So that's phi bar divided by the radius. Oh, I totally munched this. So no. That's not even what goes there. Anyway, this 1 is the hypotenuse. I don't even know what the hell I was thinking. So this hypotenuse is L, and this is 2L. You know what I mean? So But I definitely, I wanted to make this vertical component, you know, I'm just going to, yeah. So let's get rid of those bars, but I'm going to say this is phi vertical, and then this is going to be theta vertical. So that's going to be the symbol for that. I don't know, it's just, you get to use whatever symbols you want, but I think this will be helpful. So now I'm going to say that we have, all right, hell yeah. See, now I never know what to put at the beginning of my videos, because I might put this all at the end, you know, and then clean it up. But because I really like to dig in and dive in, and not just, if I run into an issue, hey, I want to explore it. So, okay, we're trying to get this as just one equation, as like one thing as a ratio to another, and it feels like it's difficult. So the sine of this angle right here is this component. Cool. So, but oh, bummer. No, it's not. The sine of this angle is this component divided by that. It's the percentage. So if this is 100 and this is 90, the sine would be 90 divided by 100, or 0.9. That would be the sine component. If this is 1 and this is 0.9, same thing. If this is 0.5 and this is 1, like a 30-degree triangle, hey, it's 0.5 divided by 1 or just 0.5. That's the sine component. Okay, so it's the ratio. So I'm going to say the sine of this angle is going to be phi vertical, which is that distance, divided by the hypotenuse, which is L, and then we're going to multiply it by L. That's why those L's cancel. Cool. And then over here, it's going to be the same thing. We're going to have the sine of this angle is going to be theta vertical divided by 2L multiplied by 2L, so those L's cancel. Cool. So then, yeah, I mean, I guess we just did an identity that, yes, this vertical component related to that angle is equal to this vertical component related to that angle. So, yep. Yeah, I'm bummed out. I almost have to pop online and just, let's go back to this. So I have sine phi divided by 2 is equal to 2 sine theta divided by 2. Why can't I simplify? I have no idea. Oh, yeah. So the next thing I want to do, keep the 2 over here. And then, so we're going to have sine phi divided by 2 divided by sine theta divided by 2. I don't think this helps us out at all. Because this is just going to be the ratio of the vertical divided by the hypotenuse, and this is the vertical divided by the hypotenuse. And isn't that ratio just no, it's not 1. It's going to be 2. Yeah. Huh. How do I simplify this? Can I just take the inverse sine of both sides? I have no idea. I just don't know what to do with that 2. So, okay, I'm going to throw in the towel, hop on the computer. Alright, hell yeah. So I did not hop on the computer, but I'm just going to go a different direction. And this is kind of cool, because I'm trying to solve the harder part of this problem. So yeah, so this is just one equation that relates, you know, phi and theta. But maybe I can't get it into a form. Maybe this is just not a solvable linear equation. I don't know. You know what I mean? I don't see where I can just get, hey, phi is equal to some constant, you know, even times a sine or a cosine phi. I just don't know if I can. This is cool, because it might be one of those problems. Don't know, because this 2 is really tripping me up. But I think I'm for sure getting tripped up enough where I can just, like, I'm confident that I'm not going to be able to figure out a linear equation like this, but we can at least say, hey, let's throw in, we know that phi is going to be 27.5, so I'm going to go sine 27.5 divided by 2. Cool, and now I'm going to multiply that by 2, and then I'm going to say, hey, that has to equal this. So now I'm going to go inverse sine of that, and then that is, and then we're going to multiply by 2, so that gives us 56.76. All right, so 50, okay, no, it was that simple. Okay, I was just, it's good to use your calculator and kind of play around with things, because I was just like, I don't know, because I estimated this to be 56 and this to be 27.5. When I threw it in my calculator, I got that. So does that just mean that I can take the inverse sine? So the inverse sine of 2, oh, never mind. Okay, so I can do it. If I take the inverse sine of both sides, I'm going to have theta divided by 2 is equal to this part. And then I'm going to multiply that by 2. So theta is 2 times inverse sine of 2 sine theta divided by 2. Okay, so as long as I leave it like that, now this is an equation. So I can throw this in my calculator as 2 inverse sine 2 sine x divided by 2. And then so for every value of phi, I'm going to generate, for every value of theta, I'm going to generate this phi. And so my x I want to be 0 to, let's just do 0 to 30, and then, 0 to 30. My y is going to be 0 to 60. Whoops. 0 to 60. Cool. So now we have a relationship between these two angles. And it basically has a slope of 2, you know what I mean? So if we figure out the slope anywhere, hey, it's about 2, you know what I mean? Let's switch up the value. It's always good to be kind of playing around with your graph, just to be like, okay, so yeah, the slope is 2. When theta is small, this slope becomes 2. So as this triangle gets hella small like that, and this angle, I don't even know what's happening. Yes, if this is my 2L, and then this is half at L, then this height, sorry, not this height, but what's half? The ratio between this angle and this angle. This angle is always going to be double that. But as your triangles get bigger, you know what I mean, where you have this is 2L, and this is, and then this is L. How are we even going to do this? So we're going to do this, where you have, so if here's L, and this is 2L, and as your angle gets steeper and taller, so if this is 2L, and this is L, hell yeah, what would this angle be? You know what I mean? We're approaching about 30 degrees, so let's go a value of 30 and find out what the ratio is. Yeah, the ratio between this angle and this angle is 2.25. So this angle is 2.25 times that angle. So if I say this angle is 30, this angle is 60. No, I'm sorry, it's 2.25. So 30, let's do 30 times 2.25. This angle is 67.5. All right, so hell yeah. So we played around with this just enough to realize, hey, it's not a one. Whatever this angle is, this angle ain't just double. You know what I mean? That's where, as I was doing this problem, I thought, oh, look at this. This is about 28, and that's 56. That's just double. So is that the clincher or whatever? You know what I mean? The trick? And I was like, nah. And so it is kind of cool to take things to the extreme. But hell yeah, if this thing is really wide, where this 2L is like hella out here, and this 1L is just proportional, and this angle is small, then for sure, you know what I mean? So now let's throw in a value of like 2 degrees. If this is 2 degrees, this angle is 4 degrees. So look at that. If this angle is 1 degree, this angle is 2 degrees, 2.0000762. So now I'm back on track of being like, hell yeah, that's why my videos are good, because we point out stuff like that. You know what I mean? Stuff that you're just like, oh, I wasn't going to play around with that at all. Okay, so that said, we have an equation. This is our equation, and it's working out, and we're going to throw in that value of 27.5, and this angle shouldn't have been 56. It should have been about 56.76, but close enough. All right, so now I want to, so here's where we're at on this problem, is that we have one equation, and it only just relates the ratio between theta and phi. But we have the cosine equation. So the cosine is this length. If we take this 2L, that's related to this length right here. So 2L cosine of this angle is that length. And this length is going to be 1L cosine of this phi divided by 2. That's that length. And these two lengths add up to be the diagonal. So we know what this diagonal is. It's going to be this squared plus this squared square root that. So sweet. So that's the next step. That's the next place we're going to go. We're going to say, hell yeah. So we have 2L squared plus 2L squared. So this squared plus this squared, square root that. Let's figure out what this is. This is going to be 4L squared plus 4L squared. That's going to be 8L squared, which is, and we have to take the square root of it. It's the same thing as taking the square root of that and then the square root of L squared. So we're going to have the square root of 8, the square root of 8 just times L. That's going to be this length. And that square root of 8 times L is going to equal 2L cosine theta divided by 2 plus L cosine phi divided by 2. And right here we already did our equation where we related the two. We know that phi is 2 inverse sine. It's not a super clean equation, but it's at least we have one equation, two equations. That's what we kind of did here. And now we can throw this one into there, and we can solve for theta. Like we can get theta as a function of L. So that means that anywhere where we have theta in our problems, we can actually just input that as a function of L. And maybe this is too complex and too much, but we'll see if things cancel. I have no idea. Okay, so we're going to throw in that theta. So let's just work on this. So we're going to have a cosine of this function divided by 2. So I'm just going to divide by 2 right now. So we're going to have the cosine of inverse sine 2 sine theta divided by 2. So now let's talk about this. What's the cosine of inverse sine? And then we have a sine. So this is where it's really good to break out a triangle. And again, I like to break out the 30-degree triangle. I think I can do this, you know what I mean? Alright, so this is going to be 1, this is going to be 0.66, this is going to be 0.5. So what I like about a 30-degree triangle, kind of just know, and you can make it a unit triangle and know all the parts, even to 3-digit accuracy. Alright, so what would cosine of anything mean? Cosine of anything is going to be, it's the angle. So if I'm saying cosine of this angle, that's going to be this 0.866. So 0.866 divided by 1, that's equal to the cosine of the angle. Cool. All right, now what's the inverse sine? I don't know why I'm struggling with this. I should probably turn off the camera and kind of play around. But inverse sine, well, what the hell sine? Sine of an angle is the ratio. So I write ratio first. I need to get better at that. But yeah, if I have the sine of an angle is a ratio. If I take the inverse sine of this, I'm taking the inverse sine of the ratio, and I'm saying, hey, that ratio is this opposite length divided by the hypotenuse length. You know, those two things. It's this opposite length divided by the hypotenuse length. And you know, anyway. So the inverse sine of that ratio. So if I take the inverse sine of this ratio, it says, hey, that it generates the angle. So the inverse sine of a ratio generates the angle. It's like, hey, if I know these two things, what's the angle right here of that triangle? Okay, so I don't know if I can simplify this at all. But I'm just going to make this generic. Just like this is just going to be some generic angle theta. And the inverse sine of the angle theta. What's the inverse sine of an angle? Oh, no, never mind. Holy hell! This is not an angle. This is a length. No. Holy hell! Now I'm confusing myself. So the sine of an angle is a percentage. That is a ratio. So the sine of an angle is a ratio. The inverse sine of this is an angle. And then the cosine of this angle is a ratio. All right, that was not helpful. But yeah, let me pause and see what I can do. All right, I know what I can talk my way into. So let's say this angle right here is like a 30-degree angle. You know what I mean? This whole angle is 56, so we're not too far off. I know that this is going to be half. So if I have a 30-degree angle, and this is a radius of L, this is 0.5 L. Okay, so now what do I know about? So then I know the sine is going to be 50%. Cool, because this is 0.5 L, and then we're set, and then I'm going to say this is 2L, and we want to know what this ratio is. Does that work? I mean, if this is 30, or maybe you can't get a 30-degree angle. I'm sure you could. Yeah, I got to pause again. All right, I got tripped up. No, hell no. No, you can't get a 30-degree angle because the reason is because by this geometry, this distance is going, this hypotenuse is going to be L, this is going to be 2L. And if we talked our way through that, and this was a 30-degree angle, this would be 0.5 L. So that meant that, well, I mean, I guess, no, the analogy works. It just means that this angle would be the inverse tangent of 0.5 divided by 2. And so that would be a 14-degree angle. And so if this was 30, this would be 14. And that's what I wanted to point out. This one's not 15. So this angle is not half of that angle. I just wanted to have a way to show that if this height was 0.5, that see, that's what's tripping me up with this problem. So what I just did there is like I'm just getting rid of the box. I have a circle with a radius of L up against a circle with a radius of 2L, and I'm pushing them and overlapping them to where this angle from the center makes a 60-degree angle. So I think, yeah, that's 100% legit. We can do that. And when we do that, this half angle is going to be 30. This height is going to be 0.5 because this is L. You know what I mean? What we know about a 30-degree triangle is the opposite is half of the radius or the hypotenuse. And the radius of this one didn't change. So this radius can still be 2L. It's not going to fit into a square no more, you know what I mean, or the kind of this nice configuration. But it does show you the relationship between this angle and that angle. And that's kind of all I wanted to point out, is that, again, that this angle, half of it, I mean, taking this 30 and dividing by 2 is not this. This will be a little bit smaller. Because of that. Now, if this angle gets real small and this becomes like 2 degrees, then hell yeah, this will be about 1 degree. And we just did an equation in our calculator vice versa. If you said this one was 15 degrees, you know what I mean, this one's going to be extra big. It's going to be like 32 or something. If this one was 14, it's not going to be 28 over here. It's going to be 30. So that's what we were showing. If this angle right here was 1 degree sliver, just very narrow, this one's basically going to be 2, but it's going to be 2 and a little bit. Is that? I don't even know if that's, yeah, this is 2, the degrees here would be 2.000762. Okay, hell yeah. That still is not helping me putting these two equations together and seeing if we can simplify that. But I'm going to try one more time. Alright, hell yeah. I don't like to think too much off camera, but this one's tricky. So what I did is so I finally got it figured out. Is like, hey, if I'm taking the inverse sine of something, that means I have the ratio over here. So if I have the common 30-degree triangle, we're going to have 0.5, 0.866, and 1. So the inverse sine means that I have the ratio. So I have 0.5. So the inverse sine of 0.5 of this triangle, which is 0.5 over 1. So if you're taking the inverse sine of something or inverse cosine of something, it's always a decimal between 0 and 1. So it's going to be like 0.2, 0.5, 0.7, I mean, you get the idea. Same with cosine. But always throw a 1 underneath this, because anytime you see inverse sine or inverse cosine, it's the ratio. So back to this 30-degree triangle. If I'm going to take the inverse sine of 0.5 divided by 1, that's the inverse sine generates the angle. What I mean? That's kind of what we're looking for. And or that's what inverse sine does. It says, hey, I have this ratio of a triangle, what's that angle? And then you pop it into your calculator. Okay, so we're going to get this angle of 30. And now it says take the cosine of that angle. Well, so that's where I just wanted to I was just like, well, can't I change this to sine in some sort of way? Yes. If this is cosine of 30, I could say this is just sine of 90 minus 30, which is sine of 60. So in this case, if I change, I could change this to say sine of 90 minus inverse sine of, let's just say, 0.5 divided by 1. So that's kind of where, we're not going to worry about that right now. We're just kind of doing a generic triangle. Cool. So now I can, well, now I don't know what I can do. But yeah, at least I could change this to sine, and we got 90 minus, I don't know if that helps me at all, actually. Alright, hell yeah. So we're back. I almost took a half-hour break because what I did is, what a great tool is the derivative calculator. Go to derivativecalculator.com, type it in Google. You can input an expression like this, with cosines, and you would say this is a sine. That's how you type it in, just with the keyboard. But you can, and then the variable here is just x. And, it takes the derivative, it's a derivative calculator, but still it changes your input. It changes your input from this to its simplified version. So that's what we have here. And I guess what I learned in the last 30 minutes, I've done this before, but just kind of once. I've made videos on hey, if you get to something like this, how the hell do you simplify this? And I guess I was paying too much attention to this, seeing that this was inverse sine of a sine, and maybe something canceled. But I think what the thing to pay attention to is this inverse sine part. If you have inverse sine, then that means that this is the ratio. So I think the golden rule is every time I see an inverse sine or an inverse cosine, you take this and divide it by 1 and then draw a triangle, because this is the ratio. So so here's our just generic triangle. And if we have the sine, it's the ratio, and this is our angle. But we have inverse sine of the ratio. The ratio is this divided by the hypotenuse. That's sine. Sine is opposite divided by hypotenuse. So here, this is going to, and this is the ratio. So it's 2 sine theta divided by 2 divided by 1. So this is going to be the opposite, sine theta divided by 2, this top part, and then the hypotenuse is 1. So cool. Now we have, now we can solve this triangle. We don't need to know what theta is at all. That's the variable that can be changing. Well, and in this case, I don't even know if I should have put theta here, because I don't think this theta is related to that theta in any way. Okay, so we do have this triangle. This is just an equation, for the ratio. Okay, but if we have this triangle that says, hey, this side is going to be 2 sine times a variable divided by 2. So whatever, we're going to choose an angle, divide it by 2, take the sine of that. Taking the sine of an angle gives us a ratio. And so, again, anytime you see sine and cosine, these are just percentages. So, they're dimensionless. So now we have 2 times, so this boils down to 2 times, like, 0.2 or 2 times 0.4, like whatever. But it's just a ratio of 2. 2 times the ratio between 0 and 1. Cool. And then we have a triangle. We have a hypotenuse and an opposite side. We know 2 things of a right triangle. That means we know everything about this triangle. And we just use Pythagorean's theorem. Pythagorean's theorem says, hey, if this is a squared, this is b, and this is c squared, hey, a squared plus b squared equals c squared. So we could write that. And it's kind of good to write that if you've never solved for, like, a. If you solve for a, you got to get that b squared over there. So we got c squared minus b squared. Hell yeah. And now we can just take the square root of that. The fast way is just knowing that if you're trying to find the hypotenuse, hell yeah, it's just this side squared plus this side squared. Square root that is equal to the hypotenuse. But if you're trying to find the side, you take the hypotenuse, square it, and then subtract the square of the side. So everything's still kind of squared, and you take the square root to get this component, but you're taking the hypotenuse, the bigger number, subtracted by one of the sides squared. So hell yeah, the hypotenuse squared, subtracted by one of the sides squared, square root that. So that's kind of a fast way to get the sides. So if this is what we have, so we're going to have 1 squared minus this squared, this whole thing squared, which is going to be 4 sine squared theta divided by 2, square root that. This is just going to be 1, but hell yeah, that's where we get that generic form of the square root of 1 minus 4 sine theta divided by 2, all that squared. Okay, hell yeah. And we had this equation, we had this, we were using back to what the hell we even doing. All right, new battery in. And yeah, it's like, what are we actually doing? Well, we related, this component because it was going to be the same. So the sine of this angle, the hypotenuse times the sine of this angle is that dimension. The hypotenuse times the sine of this angle was this dimension. We know what the hypotenuses are, we just don't know what these angles were. But we had that ratio, so that's where we got this equation. This is the ratio of this angle to this angle. Hell yeah. And more importantly, I guess it's the ratio of this angle, to this angle. But, I mean, this divided by 2 is the ratio of this angle to this angle. All right, and then we know that the cosine components are related, because here's the cosine component of this right triangle, here's the cosine component of this right triangle. If we add them up, it's equal to the diagonal distance. So that's what we did. We got the diagonal distance to be the square root of 8L, and now we're going to have it equal to this 2L cosine theta 2, and then this is L cosine phi 2. So, and then we want to shove this equation for phi into there, and so that's kind of what we did. This 2 cancels that 2, and then we get cosine inverse sine 2 sine theta divided by 2. So now we just did the cosine part. This should be L cosine. So there we go. So this L. So now this is that term right there. L square root 1 minus 4 sine theta divided by 2. And now I think we're money. Like, I even see where we can, kind of finish this off. Let's grab some more paper. But yeah, this is brutal, but I'm glad, you get to a stopping point, and maybe, that could have been a stopping point for a lot of people. It's just like, I really can't simplify that. I don't even want to deal with it. But, like, even right now, I can see that we have a sine squared right here. We just have a cosine squared, but we basically have a square root of a sine squared. I don't know if we're going to have extra terms. Well, I haven't thought of that. I don't think so. I think we're basically going to have, we're going to square both sides of the equation. Well, I don't know. I don't know. All right, let's just throw it together. So we have the square root of 8. Oof, I don't even know what I did there. But square root of 8 times L is equal to, oh yeah, because if I square, damn it. Huh. Yeah, I thought I could get just theta by itself. That was what I was wanting to. I wanted to get an equation for theta by itself. Let's see. I guess let's just write it out and see what's the next step going to be. 2L cosine theta divided by 2 plus, now we have L square root 1 minus 4 sine squared theta divided by 2. So it's sine squared theta divided by 2. Well, I guess, we can just factor out an L, no duh. And, this is what we'll have to do. I mean, yeah, I think we can trim it down. Yeah. Sorry for making weird noises. Alright, so we have square root of 8. We're going to subtract this side. So we're going to subtract 2 cosine theta divided by 2. Now we just have this all by itself over there. Now we're going to square both sides. So this side just becomes 1 minus 4 sine squared theta divided by 2. We got to square this, which becomes 8. This squared becomes plus 4 cosine squared theta divided by 2. And then we have to multiply these two together. So we're going to have minus 2 square roots of 8. There's going to be 2 of those, so we have 4 square roots of 8 cosine theta 2. All right, cool. Now this is still going to work. So we have, and then we got minus, well, let's not do that, because it's going to equal this. Let's get this the hell to the other side. So we're going to go plus 4 sine squared theta divided by 2. We'll just leave the 1 over here. So we can see that cosine squared sine squared is equal to 1. And if you don't see that, if you don't want to do it that way, do it this way. Just get your 30-degree triangle. You have an angle here. Here's your hypotenuse. This is going to be h sine theta, h cosine theta. Hell yeah. And so you can take this triangle, make it a unit triangle by just dividing everything by h. Hell yeah, that's a video in a video. So hell yeah. So now we just have sine theta, cosine theta. I think actually applying a hypotenuse that has visual measurement more than just one, unit triangles suck. No one can visualize a unit triangle just because your sides are going to be less than 1, and it's really hard to visualize fractions. Okay, but let's say, so now that we have this, like, one, you could just say, hey, these two things squared, this is Pythagorean's theorem, sine squared plus cosine squared theta is equal to 1 squared. So there's your identity right there. I thought there was another way I could do this. Well, hell yeah, there is. I mean, let's say I just want to solve for this side. So let's say I knew this was the cosine. That's how you have to really mind trick yourself. So let's say I knew what the cosine meant. I knew this is cosine of the angle, and I know this is. I just don't know what this is. All right, so let's use Pythagorean's theorem just like we did. The hypotenuse squared minus cosine squared theta, square root that. Well, hell yeah, that is equal to that. So cool. So now we have this relationship that sine squared theta is equal to the square root of 1 squared minus cosine squared theta. And now we can no. Sine theta is equal to this. Sorry. Sine theta is equal to the square root of 1 squared minus cosine squared. So if I see that I have sine squared right here, I could say, hey, that's going to be the square root of 1 squared minus cosine squared theta, and then squared. Okay, the square root goes away, and then we'll have 1 minus cosine squared theta. We have the cosine squared theta over here. So, and we're going to have this 4. So we're going to have 4 minus 4 cosine squared theta. And now 4 cosine squared theta divided by 2, I guess, minus. So I don't know. I mean, I think it's good to kind of, they're all identities, so that there's nothing magical going on. You know, you're not going to have like too many aha moments, but it is good to do that process, because what we did just right there is where I got stumped on cosine inverse sine, seeing that this inverse sine is a ratio, turning it into a ratio. Hell yeah, I got a triangle. It's the sine component. 2 sine theta divided by 2. Here's the hypotenuse. I can figure out what this is. Square root of 1 squared minus that crap squared. And it's just good to be able to do that fast, like juggle it. Not make that like an hour process of relearning every time you have to do that. So that's what I'm trying to do. I'm trying to like go through anything that I go through once, might as well kind of go back through it while you're doing it. And but we'll see if at the end of my videos, if I'm ever like, oh hell yeah, here's what I learned today. Man, my batteries are just kind of running dry. So okay, so let's do this. So this is going to be a 1, but we still have the 4 here. So we have I mean, what we're going to have is we're going to have this. We're going to have 4 cosine squared theta divided by 2 plus sine squared theta divided by 2. This becomes 1. So we don't get 8 here, but because this is like, oh man, my batteries are juicing out on me. But yeah, so even if you're looking at stuff like this, I see a sine and a cosine. I see it squared, but it's the same thing. It's a percentage squared. You know, it makes it even the same and worse. You know what I mean? What we know about percentages is like, well, if you have 0.5 squared, it's going to be less. If you have 0.99 squared, it's going to be less. So it's still, you can still look at these as percentages. This is still a percentage of 4. This is still a percentage of 4. So maybe this is 4 times 0.5, and this is 4 times 0.75. I mean, still, you're going to get, you know, you're for sure not going to get 8. You're not going to add these two together and get 8. So that's all I'm saying. But with this idea of squaring terms, you know, we have triangles where if this is a 30-degree triangle, this is 0.866, this is 0.5. Now 0.5 plus 0.866, that's like 1.3. You know what I mean? Much bigger than, but if I square these and then add them, they add up to 1. It's just kind of a cool, you know, it's the fact that fractions squared, you know, they reduce. This goes to 0.25. This is the square root of 3 divided by 2. We're going to square that. That becomes 3 divided by 4. And then we have 0.75 plus 0.25. So hell yeah, it's always a good one to do too. So this stuff, always pick like one triangle you like that you can do kind of everything with. And again, I don't mind of scribbling. It's more of talking your way through things is the most important aspect, I think, of my videos. All right, so hell yeah. So just, yeah, right there. So you could get tripped up and be like, is this 4 plus 4? No, because you have to put these together, and these two combine to 1. Booyah. And we just showed it. You know what I mean? 0.75 plus 0.25. That's going to be 0.5 squared plus 0.866 squared. Those combined to add up to 1. Cool. So we're going to have 8 plus 4 is 12. Minus 4 square roots of 8 cosine theta 2. Anything else is equal to 1. Cool. So let's say this is 11 is equal. Well, let's do a bunch of steps all at once. So we have. Sorry, I'm just trying to get on with life too. But hell yeah. So what I did right there is took the 1 over here, that subtracts. So we have 11. Took this over there, we got the negative, right? It's easy to see. And then we had to take 11 divided by that. And so we're going to get 11, 4 square roots of 8. This side we're going to have cosine theta 2. Now I'm going to take the inverse cosine of that. So I'm going to take the inverse cosine of this side and that side, and this is going to be theta divided by 2. I'm going to multiply over here by 2. So we're going to have 2 inverse cosine 11 4 square roots of 8 is equal to theta. Hell yeah. And hopefully this just works. You know what I mean? But, well, even right now, what the hell should I do? I see an inverse cosine. I'm going to play my own game of being like, hey, every time I see an inverse cosine, divide it by 1. Well, in this case, I already have a ratio. So this is going to be a triangle where, and this is some sort of angle. And this is, you know what I mean? Taking the inverse cosine of a ratio, this generates the angle. This multiplies that angle by 2. You know what I mean? So hell yeah. So let's just do that. So this is angle, you know, angle naught. This angle is phi, this angle is theta, where theta is theta naught times 2, or 2 theta naught. So see how this is just 2 times some sort of angle, you know, theta naught, hell yeah. So that's what this boils down to, and that's going to be theta. So I don't know, just to show you what this equation is. But what do we know about cosine? Cosine says that, hey, if I have the ratio, this is the cosine component, this is the hypotenuse. Cosine is always the adjacent divided by the hypotenuse. That's the ratio involved. So we have 11, and this is 4 square roots of 8. Cool. Now, what do we, so what? Yeah, I don't know. I mean, I guess we should almost just take this as a decimal. What's the square root of 8? Square root of 8 is really close to the square root of 9. That's really close to 3. Let's just call it 3, and we got 11 divided by 12. We almost got like if it was 10 divided by, if it was 9 divided by 10, that would be 0.9. Let's see, do we have more than 0.9? See, I like doing this. Mental math. If I have 9 divided by 10, that's 0.9. But let's say I increase, I don't know. It is going to be kind of, I don't know how you kind of simplify this. 11 divided by 12? I don't think anyone knows. Honestly, holy hell. Well, I know what 11 divided by 10 is. Okay, that's going to be 1.1. That's a good place to start. 11 divided by 10, that really is. That is an excellent place to start. Now, do I know what 11 divided by 20 is? Well, that's going to be, and this is just 1/2, and then 1 divided by 10. So it's just half of this. What's half of 11? That's going to be 0.55. So, hell yeah. So now we're getting somewhere. I don't think there's any easy game to, to do mental math. But since we're deep into this video, we're going to take a little, oh man, my battery's going to run dead. I guess it's all right. But yeah, and we'll, so where are we at on this? How about if we did, what's, I don't even know. What's 1/4 times, no, I have no idea. Oh, we would need to do something like 3/4 times, yeah, I have no idea. Anyway, let's just use our calculator. 11 divided by 12. What do I think it is? You know what I mean? I think it's like 0.97. It's 0.92. I was way off. 0.916. Okay, I don't even know what the hell I was doing there. But anyway, so that's the ratio. So we're going to have, if here's the hypotenuse, I guess I should do it like this. If here's the hypotenuse and we bring it down into a sweeping arc, this is the cosine component. This is going to be 1. This is going to be 0.196. So now we have to figure out what kind of angle that is. Oh, this is what I was getting at. It was just like, hell yeah. Well, if we know that this is 11 and this is 4 square roots of 8, I really want to know what this is. Because I think if I knew the sine component, yeah, that's what I was going for. Because then I can easily, if I know the sine component, I'm just in. No one knows the ratio. If you're saying the cosine component is 0.92, no one knows the angle of that. It's not very easy. But let's do it the fast way. So if I know this cosine component's 0.92, that's going to be the simplest. So I have 0.916. I'm going to store that as x. And I want to know this value. Cool. So this is x in my calculator. I have a... now what do I have? Oh, and why are we even guessing? Holy Toledo. So we have, what do we have here? So we have, this component's 11. This is 4 square roots of 8. We want to turn this into a unit triangle, so we actually divide this by 4 square roots of 8. We just divide the whole triangle by 4 square roots of 8. And so that gives us that ratio. So now this hypotenuse becomes 1, and this becomes 1.196. Sorry to gloss really fast over that. But if I want this, again, we're going to use those skills. Here's the hypotenuse. So we're going to take the hypotenuse squared minus one of the side squareds. Alright, hell yeah. Took a big break, but we're back. And it was pretty cool because I got to think about, taking the inverse cosine. What the hell does that mean? Well, it's always, if you do have this fraction, it's always going to be a percentage between 0 and 1. You know what I mean? So in our case, it's 0.196. That's going to be the unit triangle. And I should be able to do this in my head because it's going to be this squared plus this squared equals 1, and you always want to do it in reverse. So like what's 0.916 squared? Well, I'm going to look at this, no calculator, and say, well, I don't know what 0.916 squared is. I don't even know what this times itself is. You know what I mean? That's what square means. But how about just 9 times 9? Do I know what that is? Hell yeah, that's 81. So why is it so hard to relate 0.916 squared, to mean to just 0.81? That's a close enough estimate. Maybe just 0.812 increase it. But what we did there is says 9 times 9 is 81. And so 0.9 times 0.9 is move the decimal place is 0.9. I'm sorry. I also, it's bizarre to me when I watch my videos. It's like, why can't I just say the numbers I'm looking at? It's really easy to get dyslexia or just say something just totally wrong. But anyway, 0.18. See, why did I call that point? Yeah, dyslexia a little bit maybe. But this is 81, 0.81. Cool. So then, what do you have to add to 0.8, basically, to get 1? Well, you have to add 0.2. So then the question is, what two things multiplied together give you 2? You know what I mean? So, well, I know the square root of 2 is 1.4, so it looks like 1.4 times 1.4 is going to be 2. And maybe you didn't know what, so then you would do like 20. What two things multiplied? Nah, you'd have to do 200. But yeah, what two things multiplied gets you to 200? That's going to be 14 times 14. The way I do this is, hell yeah, I got 10 times 10 is 100. 10 times 4 is 40. 10 times 4 is, so I got 80. So it's 180. 4 times 4 is 16. So I got 196. Hell yeah. So yeah, people say stay away from the calculator, so my videos are just going to get twice as long because we got to go through all the mental math. But it is, especially on this one, it's very good. So right now I can see that this percentage is going to be, I don't even know, is it going to be 0.14? So 0.14 squared times 0.196 squared. This is going to be 0.9 times 0.9, which is 0.81. This is going to be 14 times 14, or 1.4 times 1.4, which is 2, or just 0.2 in this case. Is that right? I don't think that's right at all. No, why am I messing that one up? Yeah, because I already know what the answer. The answer should be like an angle of 20. No, never mind. No, I don't know what I'm thinking. Yeah, the angle that we're shooting for is about 15 degrees. This is 27.5, and we're going to be about 14 degrees, 15 degrees. So what do I know that is in radians? I know that in radians is going to be, 30 degrees in radians is going to be 0.5. So this in radians is going to be like 0.25. So that's that's the other aspect. That's kind of what I was shooting for. I was kind of shooting for like 0.25 here. Because that means that this angle is about 15 degrees. Now, if it's less, if it's like, if it's 0.14, which it probably is. I don't know why I'm not able to do this in reverse. It's kind of tripping me out. Yeah, I think I messed up. Yeah, what two numbers multiplied together get you 0.2? Yeah, I'm sorry. That's where I messed up. And let's do this. So if this was 0.9, this is going to be 0.82. That's what I thought, 0.82. So then you're going to have 18.18. That's what you're going to have to add it to. So what two numbers multiplied together get you 0.1? Am I saying that right? What two fractions multiplied together? So if I had 0.2 times 0.2, well, that's going to be 0.04. So that's nowhere near. So I would say I'd need like 0.5 times 0.5. Well, that's 0.25. Yeah, this is where fractions are super tricky, because a half, draw a square, if this is a square of 1. If this is half, but we're just taking half of a half, it's 0.25. So that's 0.5 times 0.5 is 0.25. It's really trippy multiplying. And so what we just did is said, hey, 0.92 No, and I think, did we do the... Oh, this is bizarre. Okay, yeah, because right here we have to square this to get that 0.82. And then we have to add it to a number like 0.18 to get 1. But now we have to say, hey, what two decimals multiplied together get us 0.18? And so start with halves. So half of a half is 0.25. How about 0.4 times 0.4? Well, that's going to be 0.16. So just right there, it's going to be more than 0.4. So that's pretty wild. Or it's going to be really close to 0.4. Yeah, that's trippy. And if that's the case, it's going to be more than 0.4. So yeah, 0.4 times 0.4 is 16. Move the decimal place. That's 0.16. So 0.16 plus 0.82, that's going to give us 0.98. So pretty close to 1. And hell yeah. So that means that this part right there is 0.4. So even, yeah, that's bizarre. Because even if your cosine is a really high number like 0.18, sorry, I don't know why I'm saying wrong numbers. 0.916, this distance can still be a pretty good size. And so it's always good to actually draw a picture. All right, hell yeah. So, yeah, let's do this. So if I have, and maybe we'll bust out this. If you got metric, it works pretty sweet because we're gonna do a hypotenuse of 10. And then we got a cosine of 0.9, what is it? 0.91. So 0.91. And what we're kind of shooting for is where, I could do 0.91 there, but hey, look at this. This isn't a 90-degree angle. So we got to come down, we want basically a 90-degree angle from here to match up. And so that's really wild that... that you basically can get to right there. So this distance is 0.916. This distance is 1.000. So not too much difference, but that makes this angle 0.4. So that's really wild. That's 0.4. So sweet. So we just graphically did it, and I think that's important. Anyway, let's go to our inverse cosine. After all of that, I don't even know if we did it right, but we got 11 divided by 4 divided by a square root of 8. And, whoops. I don't know why that's not working. 11 divided by 4 divided by the square root of 8. Yeah, what the hell? Inverse cosine. Why didn't that one work? So we have inverse. Yeah, what's up with this? Maybe this messed it up. Inverse cosine of 11 divided by 4 divided by square root of 8. Oh yes, it's just giving me the angle in degrees. So we're going to have 13.5 degrees. And that's not the right answer. No. Because 20, so yeah, multiplied by 2, no, that's the right answer. Times 2. Yeah, so hell yeah. So when I estimated this angle to be 27.5, I wasn't too far off. This angle is actually 27.04. So actually I don't think I made any mistakes because that's another way to check to see if you potentially did make mistakes because we did this graphically, found the angle to be 27.5. That means that this angle is going to be half that. What's half of 27.5? Well, half of 28 is 14, so it's 13.75. And so our answer is 13.52. So that's going to be theta. Theta is 13.52. And sweet. So we did it. So we figured out. And hell yeah. So now we're slow rolling this, but we're gonna get to a final answer. Oh yeah, we just been taking our sweet time. I totally forgot what equation we were even doing. So we have that theta prime. Heck yeah, that's going to be that 13.5 because that was going to be this part. All we did was solve for that part. Multiplied by 2, that's going to give us that full angle. And so that was that 27. So our theta for our problem that we've been doing is going to be 27.04. I'm going to store that. I'm going to, store that as alpha theta. Okay, so now we can go back. So now we know what theta is. And let's see if I can even find any of my notes. Because it's always good to, not go back to your equations, just go back to the fundamentals of the problem. Because we have the sine component of this, so we're going to have 2L sine theta divided by 2. So that's this angle right here. That's that component. That's going to equal L sine phi divided by 2. Cool. So now we're just going to solve for phi. So L's can cancel. We're going to take the inverse sine of this side and multiply by 2. So that's going to be phi. So we're going to have 2 inverse sine of... oh yeah, and then today I was so tripped up when you have inverse sine of 2 times sine. Yeah, you can't really simplify that. If you had inverse sine of just sine, then you're just good to go. But you have to treat this as the ratio. So let's pretend, let's do something. Let's say this was inverse sine of just sine theta divided by 2. So I have an inverse sine. I'm going to take this divide by 1. Draw my triangle. So this is going to be sine theta divided by 2. This is going to be 1. So now I'm going to figure out what this side is. Well, it's going to be 1 squared minus sine squared. So we have sine squared theta divided by 2, and then the square root of that. Cool. So then when, that doesn't help me out any here, I don't think. What the hell does this even mean? Oh, inverse sine of this ratio is just, well, it's just the angle right there. So that is just given the angle of the triangle. Then in our problem, we had like cosine of that. Okay, then if we took the cosine of this angle of this triangle, hell yeah, that's going to be this adjacent divided by 1. So yeah, I'm still a little bit rusty when it comes to that. So anyway, let's solve for phi. So we have 2 inverse sine. What else? We have 2 sine theta divided by 2. So yeah, get where you can see, and then that's it, because that's we inverse signed it. That part's already taken care of. This 2 is already taken care of. So we just left with phi, and so phi is 55.77. That's very close to 56. So I'm good there. I'm going to store that as alpha z. All right, now we can just kind of go back to the original problem, and so hell yeah. So I'm going to say this. I'm going to say, hey, the area of this triangle is the area of a 2L triangle. So we have the area of a circle is pi, radius is 2L. So we're going to have 4L squared. So there you go. This is pi r squared. We just took the radius was 2L, and then we just squared it. So that's going to be 2L squared. That's going to be 4L squared. So yeah, I like doing it just kind of in one step, but I'll definitely show you the little steps I do. All right, so that's the area of this full circle. We need to know the percentage of this wedge. So that's going to be the ratio of theta. We found it now. It's in our calculator. And hell yeah, so that's the area of this wedge. We just want half the area of the wedge. Well, no. We're already beyond that. You know, we know what we're doing now. So if I have the area of this wedge, I'm going to then subtract the triangle portion, which is, you could just say it's one triangle, 1/2 base times height, or instead of 1/2, we just know that it's just base times height is the area of both these triangles. Like, even though they're triangles, these make a rectangle. Hell yeah. So that's kind of cool that you can visualize that rectangle. That's probably the most important thing that I learned today in this video. Okay, so we're going to subtract. So we have the area of this wedge, and pizza-shaped wedge. And then we're going to subtract the rectangle. That's subtracting the base. That's going to be 2L cosine of the angle theta divided by 2. Cool. And then we're going to multiply it by 2L sine theta divided by 2. So we're going to have that 2L squared again. So we're going to have 4L squared. And then we got I'll do the cosine component. The base first. theta divided by 2, and then sine theta divided by 2. And again, what the hell did I just do? The base is going to be the radius, so that's going to be either r cosine of the angle, and the angle is theta divided by 2, times r sine theta divided by 2. So that's the base times the height. And we're not doing 1/2 because we want the whole rectangle. All right, sweet. So, or you could throw a h in there for the hypotenuse. The hypotenuse, cosine theta divided by 2. Hypotenuse, sine theta divided by 2. All of these you could switch to just r squared cosine, sine, the two components. Or you could have the h out front, cosine, sine. And so what we just did is we said that the radius is L, or 2L squared. That is our hypotenuse, that is our radius. So we have 4L squared, and then the cosine part, sine part. So that's what we have, 4L squared, cosine part, sine part. All right, and that's going to give us this wedge, you know what I mean? Because we're taking the full wedge, and then minus the two triangles, and that gives us this, this remainder piece right there. We want the other remainder piece from that triangle. So we're going to add this stuff to the area of that circle. So it's pi r squared. The radius is L. So we have pi L squared. So we got pi L squared. Cool. And then the whatever angle that is, that's going to be phi divided by 360. So phi in our calculator is alpha z. Theta in our calculator is alpha theta. All right, hell yeah. And then we're going to subtract this triangle. That's going to be base. So we're going to have the hypotenuse. So, but L squared cosine phi divided by 2 sine phi divided by 2. So hell yeah. So you're same thing. You're going to have the base is this part is going to be the hypotenuse cosine of theta divided by 2. So you have L cosine theta divided by 2. The height is going to be L sine theta divided by 2. But I just brought out the L's in front. Cool. So now you can factor out all these L's. So you're going to have L squared. And then everything else is a constant that we can put into our calculator. And let's just do it instead of writing it again. So we're going to have 4 pi. And like, I can't even make a mistake because we've already done this 1,000 times and we're going to get 0.11. If we get anything drastically different, I would be surprised. All right, hell yeah. So then we have theta divided by 360 minus 4 cosine theta divided by 2 sine theta divided by 2. Okay, plus pi, pi phi, which is z divided by 360, minus cosine phi, which is z divided by 2. It's phi divided by 2, so that's going to be z divided by 2 in my calculator. All right, and then sine phi divided by 2. And again, phi is z. I'm sure you see that by now. All right, and enter. And we get something a little bit different. So, and hell yeah, as we should expect, because this is the more correct answer. We got an answer of 0.11, but our thetas and our angles were wrong. So, but I'm still going to double check. So we have 0.197. Oh, and I got to get used to this. Anytime where you forget to round, like at 3 digits, well, and you should, unless it's the final answer. The pros at MIT, I've been watching some professor videos. Hey, they just do this. They just do ... So that just indicates, hey, I'm done. I'm sure there's more numbers, you know what I mean? But I'm done. You know what I mean? Hey, these 5 are plenty. And you can see that we could round this to 0.108. So there you go. There's kind of the answer. That area is 0.108 L squared. And let's just throw in our values for theta. So if we had 27.5, and I'm going to store that is alpha theta. I shouldn't have done that, but whatever. And then 56 stored as alpha z. So now what we're going to do is just run that equation again. And yeah, we get that answer that we've got all along, 0.11. So sweet. So this is the actual answer. And I don't know, this problem bummed me out because I thought there was just some sort of fancy, easy trick that you could do to get, like on the same page right away. And I'm sure there is, but I don't think I took a too difficult method. I was just surprised that I couldn't see the equations and the unknowns and I'm sure there's still an easier way, but I'm not going to look at the answer. These are like puzzles. So what I would recommend is that I'm going to use my brother as kind of a person that I can be like, hey, I got as far as I wanted to on this puzzle, and then just ask them. You know, like it's kind of like a puzzle buddy. Be like, hey, should I spend more time on this puzzle, or is this puzzle just totally stupid? You know what I mean? Or is the trick, like no one's ever going to figure out the trick, so you just look at it and it'll help you longer term. So it's just interesting, because the second you look at the answer of a puzzle, it's ruined. You know, it's like watching a movie in reverse is no fun. Like watching the ending of a movie before. Yeah, it's so anyway. So, but on this, I'm surprised that I'm not surprised. Well, I am kind of surprised. So what we did was we started with what we thought we knew, what we could do, and then we actually found out an exact solution that I was just surprised about. It took me a while. Like none of this is like easy for me, that's for sure. So now I don't even know what I'm gonna do. Could I make a shorter video on this? I don't think so. I think I'm just gonna throw in the towel and say, hell yeah, we did it. We got an answer. And I don't know. I think this method is just very fascinating, where you just kind of know what you know. We did guesstimation. You know, you get like that fast answer. Our initial answer, we thought it was going to be between 0.125 and 0.25. And, you know, we even missed, like right off the bat, we realized that we missed the mark even there. Like, hey, this is close. Like even if we said, hey, it's within this range, but or plus and minus outside the range. Like this is our target range. But hell yeah. So we would have been, like if we chose this as our value, we would have been more than half 50% error. But if we chose 0.125 as our answer, hey, our error is not too bad. That's going to be 0.125 minus 0.108 divided by 0.108 times 100. So there you go. We had a 15% error at best, else we had a 0.25 minus 0.108 divided by 0.108 times 100. Else we had anywhere from 15% to 131% error. So definitely our initial guess was pretty it was all right. I mean, actually, like why am I even bashing this initial guess? Because this initial guess is to get you with an order of magnitude of 10. Now, if you are so like you're trying to capture your answer. Like if the answer is 50 and you say it's 500 or 5, hey, then you kind of have an issue. So if the actual answer is 0.1 and I said the answer was 1 or 0.01, hell yeah. See the difference there? So if I said the answer is 1, it's 1 minus 0.1 divided by 0.1 times 100. That would be a 900% error. All right, so hell yeah. So there's this, yeah, so you don't want to be off by a factor of 10, but right here we're just off by a factor of 2. Now the error is 100% error because we're off by a factor of 2 and a little bit more. But yeah, so when it comes to your initial guess, you're trying not to be off by more than a factor of 10. So if the answer is 50 and I say 5 or 500, hey, not the end of the world. You're off by a factor of 10x in both directions, whether you said 5 but that's still better. It's better to be off by 10x than 10 to the 3x. You know, 10 to the negative 3x. You know what I mean? So so your initial guess is just to try to capture your answer within, I would say, and I like that. I like that range of like a factor of 10 in both directions. So again, if our answer was 0.108, if we captured our answer by saying 1.08 or 0.0108, like that's a satisfactory first guess. And if you're able to do that in your first guess very quickly, then hell yeah. So let's go back and see if we could have done that very quickly in our first guess. So, and then let's see if we could do this. So if our area is going to be so L is going to be 1. Yeah, this is really fascinating to me. So if L is 1, this area of this, so this side is 2, the area of this square is 4, then I need to figure out, just guesstimate the area of this wedge. If I guesstimated that the area was that, like a quarter, you know what I mean? Obviously, it's not more than a quarter. But I'm going to say, hey, that's the high end. I'm going to say it's an area of 1. If this whole thing's 4, I'm going to say this thing is an area of 1. Cool. And then let's divvy this up again. So we have, so now this is 0.25, and then I'm going to do this. 0.25, and then so that's a quarter, and then I'm going to take a quarter of a quarter. That's 1/16. I don't know what 1 divided by 16. 1 divided by 10 is 0.1. 1 divided by 20 is 0.05. So this must be kind of, I don't know, halfway-ish. Who cares? So it's going to be 0.08. And then you even see, it's like, hell yeah. Well, we could even do worse. Like even if I said this was 1/20th, 0.05, we could have done another square. So let's do that. So we have this is 1 divided by 4. This is 0.25 divided by 4. So one of these is 0.0625. So I can even see that it's actually fairly close to 0.0625, maybe just double that. But maybe not even double, maybe not two, like these both together, like 0.12. I don't know, it's hard to see. It's like this could be bigger than that. But hell yeah. So then if I had one of these squares, then I could even divide it by 4 again and get 0.015. So even just that square right there is right in this ballpark. So if I estimated the area of this to be one of the, and then I'll just do 1. So if I estimated the area to be one of those squares or one of these squares, no, one of these squares. Holy Toledo! So that's a magnitude error of 10 on both directions. So if I said that this area was that square or this square, that's going to be an order of magnitude of 10 in both directions. So it's not captured by an order of magnitude of 10, but it's taking the exact answer of 0.108 and then multiplying it by 10 and then dividing it by 10. So that is an order of magnitude of 100. So that's a range of 100. So hell yeah. So I guess if you're trying to capture an order of magnitude of 10, does that mean that you would have a 5x in one direction and a divide by 5? I don't think so. That's where, like, I have no idea. Oh, that was tripping me out. I didn't want to end on something I didn't know. No, if we wanted to do that, you know, if our answer was 0.108 and we wanted if we wanted to have this as our midpoint, 0.108, and then have two guesses that the range between these two guesses was an order of magnitude of just 10. So if I took this multiplied by 10, I would get that. If I had this divided by 10, I would get that. So this seems kind of complicated. I just kind of realized the guess was, you know what I mean, if I multiplied this by 5 and divided this by 5, well, that doesn't, I don't know why that doesn't work. Well, let's just pick something that's, so if I had 5 as the midpoint, and I multiplied by 5, I would get 25. 5 divided by 5, I would get 1. And then I could see that this gap is a multiple of 25. It's not a multiple of 10. So I would have to reduce this. And what I would reduce it to is 3.333 repeat. So if I had 10 thirds, so I would take 0.108 times 10, and let's just do it with 5. So 5 times 10 divided by 3, 10 thirds times 5. So I would have 16.6, and then 5 divided by 10 thirds is 1.5. Oh, and that's not the right answer either. Okay, hell yeah. So we're gonna see what this answer is. So basically, this is A, this is B, and then I want to say that B divided by A is 10. Cool, so that's one equation, because when I take this divided by 1.5, I want to get 10. Now this is going to be just about 11. Okay, hell yeah, so that's the first part of the equation. And then what else? And then I have, I'm going to call this x, this is my variable x. And then I'm going to say x, x times, well, and then this is the answer I'm going to try to find. And I kind of like to do this as variables, just draw a box. So I'm going to have x times the box is equal to b. And then I'm going to have x divided by the box is equal to a. So now I have two equations, a and b. I have three equations, three unknowns, right? I don't know a, I don't know b, and I don't know the box. So there's 1, 2, 3. So anytime you get three equations, three unknowns, always search for the equation that has both of, has more unknowns, I think. You know what I mean? Like this has a and b, and then this is already equal to a, this is already equal to b. So we're going to throw this one in for b, so we're going to have x box divided by, here's a, so we have x, and then we get the x divided by box is equal to 10. So this x divided by box, the box goes upstairs, so we have x divided by x, and we have box squared. So we're going to have the square root of 10. Oh, that's why I was close. It's the square root of 10. The square root of 10 is about 0.31, I think, right? So, and we should also do this without our calculator, because 3 times 3 is 9, 4 times 4 is 16. So, hey, you know, we don't have to go up too much. 31 times 31, 30 times 30 is 900, and then we have 30 plus 30 is 60, and then 2, and then 1. So sorry, so that's 961. Is that right? And so it's going to be more than 0.31. Let's see, what the hell is the square root of 10? Maybe it's 0.32. Square root of 10 is 0.316. Oh yeah, I remember it was really close to pi. So the square root of 10 is very close to pi. Alright, hell yeah. So, cool. I'm going to remember that now. If I want to do a, hell yeah, let's just remember it as pi. So if I want a 10x multiple, I'm going to take the answer that I'm striving for, 0.108, multiplied by, or let's say the answer that I get. Let's say I had an initial guess, and I wanted to know whether it was in this range. Because my guesses of 0.125 and 0.25, I just wanted to know where they were in the range of this factor of 10. And the actual answer was 0.108. So I'm going to take 0.108 multiplied by pi, and then 0.108 divided by pi. So there you go. Right then I can see if my guess was more than 0.339, I got issues. But it wasn't, you know what I mean? So it's still within a factor of 10. We hit the midpoint within an order of magnitude of 10. If this low end was less than 0.03, hell yeah. So, I don't know, I'm just not very good at making quick videos. I think in the future I could, but you know, I want to, you know, even just this is a find. Hell yeah. Like whatever the answer was, multiply by pi, divided by pi, and you have an order of magnitude of 10. And I think that's going to be easier to remember than the square root of 10. Multiplying by the square root of 10 and dividing by the square root of 10. But, booyah. And let's do that. 0.108. Well, yeah, so both these numbers, if I took this number divided by that number, it's basically 10. 0.108 times the square root of 10, 0.108 divided by the square root of 10, and these numbers are just off by 10. Hell yeah. Okay, so what the hell are we even doing? I kind of blacked out there. No, seriously, what were we trying to explain the exact answer, or were we trying to, oh, we just knew that was our answer, and we just said, hey, that was our guess. But yeah, I think I'm done with this video. I think we did it. I think we got a pretty satisfactory right answer, and who knows if I'm going to make a little, I don't know, it seemed complex. It seemed too complex to explain in that little, in this. I'm not, you know, do you want to see the answer? Might as well. Like, I don't want to look at it, but you can. So here you go. So here's it's interesting, intersecting circles. I'll kind of pause it here so you can, pause the video. And then here's the answers. And I ain't looking at them. No way. You know what I mean? This is where you need, that's where we were talking about. You need someone to, okay, and then the next page. And I'm not going to look at it. There's no reason to look at that crap. There you go. Okay, so I kind of saw that triangle. And it seemed like exactly what we were doing. But I have no idea, you know what I mean? Okay, so there you go. There's the actual answer. I don't know. But yeah, even right there. I kind of want to make a shorter video that my brother could tolerate. He can tolerate 2 minutes of this. And then ask him as just like, hey, did I get the answer right? Or was there something simpler? But I don't know. Yeah, always have a puzzle buddy. And never just, I don't know. Some puzzles, yeah, even if you want to look for the answer, ask someone if you should. Is it going to be worthwhile for you? Or should you ponder it? I think my limit's going to be 1 year. Like, hey, if I get a problem and can't answer it in 1 year, then go look at the answer. But it's really difficult because it's too tempting just to be like, nah, throw in the towel right away. All right, hell yeah. So I'm done with this. Thanks for joining me. Professor, I think it's Povies. Do you say the O as an O, Povey? Because there's the E, I think. Anyway, Professor Povey's Perplexing Problems, pre-university. Yeah, if you go to Harvard. All right, hell yeah. So thanks for joining me, and that's a video.